Hello, everyone. Welcome to the third annual WorldShop International FTC Conference. My name is Shrey Goyle, and I'm from FTC Team 12808 Revamped Robotics, and I'll be your stream moderator for today. The conference will host teams from all around the US and Romania in segments of presentations on technical and non-technical topics. Here's the agenda for today's conference. We'll start with Team 6369 Designosaurs from Minnesota, USA, presenting on team dynamics. Next, we have Team 12808 Revamped Robotics from Oregon, USA, presenting on drivetrain control. Then, we have Team 14278 Team Zio from Alba Iulia, Romania, presenting on outreach. After an hour break, Team 6486 Suffern Robotics from New York, USA, presenting on mechanical design, will be up next. Last but not least, we'll conclude our conference with Team 7593 from California, USA, who will present on robust documentation. Please drop your questions in the stream chat as we have representatives from the presenting teams ready to answer your questions. If we don't get through all the questions in time, you'll find the team's contact information displayed at the end of their presentation. Feel free to reach out to them. Finally, I'd like to give a special thanks to Fund FTC for hosting us on their platform to stream and promote our conference. I hope everyone is excited to hear and learn from our fellow FTC teams. Now, let's get started with the first presentation from the Designosaurs.
Hello everybody and welcome to our presentation for WorldShop. We are Team 6369, the Designosaurs from Minnesota, and today we'll be talking about team dynamics. Let's get started. Before we actually jump into the content of our presentation and what we'll be talking about, I wanted to go ahead and start with some introductions so you can get to know my team. Like I said, we are Team 6369, the Designosaurs from Minnesota. This season, our team has 4 members, consisting of 3 seniors and 1 junior, and the Designosaurs have actually been in existence for a whopping 13 years now, but the people that are currently on the team have only been around for about 5 years. So you can get a clearer picture of what my team is like this season, here's a quick video that expresses our personalities and team dynamic better.
Welcome, STEM adventurers!
This is a story about Sarah.
The castle of King Woodith is under attack. Buying milk is a constraint.
Robbie is never going to financially recover from this.
No, they're my bangs.
Oh, do you want me to see the boat part?
I really want to. I don't care.
That was much more impressive.
Reconstruction.
I don't know if the
Wait,
camera's
Kirsten,
rolling.
you
It
have
is.
paper in it.
And always remember to keep thinking, Designosaurs.
So yeah, I personally think that video does a pretty good job of explaining and depicting our team personality and team dynamic overall. In this picture here, you can see left to right, I'm in the red mask, and then there's Kirsten, who is our junior this year, and then we have Robbie, he's the one that has a chair over his head, and then Eric sitting with the blue tape, box taper. That's Eric, he is also a senior. A little bit about me, some things that you can know is that on my team I specialize in notebook and outreach. I'm very passionate about getting teams together and meeting new people. When I joined robotics, the thing that I was most drawn to is the community aspect of FIRST and how much it's built on collaboration and gracious professionalism, and that was very attractive to me, and that's the part that I find most fun about robotics. There are a lot of things that I just learned over the years from being in FTC. This is actually my 5th season in FTC and 8th year of FIRST experience overall. So I've certainly had my fair share of experiences, team up and down moments, and just learning a lot. A lot of the things I'm going to be talking about today I can share from a pretty direct point of view of things that I experienced and actually went through. So I won't just be going over definitions of team roles and responsibilities, but I'll actually be walking through different interactions and team conflicts and really diving deep into team dynamics, what that means for everybody, and really just get into it. So with that being said, let's go ahead and get started. When I first started brainstorming and creating this presentation, I knew that I wanted to talk about team dynamics in a team setting, and I wanted to talk about roles and responsibilities and all those things. But I got a little stuck and a little pinned, and I wanted to more explore team dynamics, so I just hopped on Google really quick and I typed in team dynamics, and this image came up. And it kind of inspired me. I liked how the image really depicted that a team has to work together, and without one person doing their job, everything is potentially going to fall apart. And team dynamics and working together is super important. So I'm going to apply that thinking to multiple areas of team dynamics in FTC. And these are some of the things I'm going to talk about today. A to-do list for the presentation. This is what we're going to go over. Starting with priorities for successful dynamics. This is going to be specifically on what kinds of things you can establish at the beginning of your season to make sure that you're having successful interactions within your team throughout your entire year. Next, we're going to talk about team relationships and what they should be built on. We're going to talk about the values that your team should prioritize and the different things that you should encourage throughout your season. Next, we're going to talk about how to create sub-teams and give out roles and individual responsibilities within your team. We're going to talk about the benefits and disadvantages to sub-teams and individual titles. We're going to go over team captains and what do team leaders look like. We'll also talk about how to give out your team roles at the beginning of your season. We're also going to go over what different sub-teams look like in the different areas of FTC, very broadly with the robot, notebook, business, and outreach areas. And then we're going to talk about individual roles and go over what their responsibilities are with their own title. Okay, and then next we're going to talk about how to facilitate productive meetings. Team dynamics heavily influence the productivity of your team, so we're going to apply those team dynamics to how to facilitate your meetings better. Then we're going to talk about how to resolve team conflict in lots of different areas and in different scenarios. I think this conversation will be beneficial to anybody listening, and for whatever position you're in, if you're a student or a coach or a mentor, this is going to be very applicable to everybody. We're going to go over disagreements between team members, disagreements on one-on-one levels, disagreements between sub-teams, what to do when somebody doesn't want to do certain tasks, how to deal with losing motivation or losing interest within your team, and different scenarios like that. We're also going to go over how to resolve conflicts at tournaments, how to resolve conflicts in meetings, and how to resolve conflicts at outreach events, and go over some tips and tricks to kind of move your way through that and talk about the different perspectives of those conflicts. Then we're going to take all the things that we had already talked about and apply it to team dynamics with different settings and groups. So the different settings include team dynamics, what they look like at meetings, as opposed to what they should look like at tournaments, what they should look like at outreach events, because it does shift, okay? There are different dynamics that are applied and come forth in those different settings. So we're going to go over those, and then finally we're going to talk about how your team dynamics change and interact and are influenced by different groups. So for instance, how does your team dynamic, how are they influenced by coaches? How are you influenced by mentors? How does the coach's role change over time? Does it change? Kind of talk about and discuss that experience. And then also, how do your team dynamics work with other parents, other students, your community, and your professionals? So really talk about how you're influenced. Oh, and then finally, team dynamics at the tournament and how that setting can heavily influence your team. All right, let's go ahead and get started with priorities for successful dynamics. So these are the things that I believe teams should prioritize at the beginning of their season and throughout their season. Just very brief things that people should keep in mind and remember and make a part of the values of your team. So the first one is get to know each other at the beginning of your season. I think at the beginning of your season, lots of teams experience taking in new members, letting old members go because they're graduating, and the dynamic of your team shifts every year. And I think this is something lots of people experience. One way that you can kind of help figure out that new flow and kind of recenter and regroup your people is to get to know each other. more you know each other, the more cohesive you will be. And the more cohesive your team is, the better you'll work together. So I would recommend having opportunities for everyone to share about themselves, really be interested in getting to know your team members so you guys are actually friends and you enjoy being around each other and you enjoy learning about each other, because this will overall really improve how your team works together because you like each other, right? The next thing I would say is understand each other's priorities and circumstances. This means at the beginning of your season, your whole team can sit down and kind of talk about where everybody stands for the season. What is your competitive level? What is each person's goals and what are they working towards? Try and center your priorities as a team and see where everyone is coming from and what everyone is really striving for. That way you kind of know as a general goal what your team is going for. And that will help your team dynamics because you're all on the same page from the beginning of the season. The next really important point for that line is understand each other's circumstances. At the beginning of your season, your team is responsible for seeing what the commitment level of everybody is and what their circumstances are. For somebody who has a job for 3 or 4 nights out of the week, they might not be as available to me as somebody that doesn't have a job. Or if somebody has soccer practice and dance and math team, they're going to be more busy than somebody that just does robotics. So their circumstances affect their commitment level. And if everybody understands each other's commitments and circumstances at the beginning of the year, that's going to be easier to understand how much that person is willing to put into your team and can lead to less frustration throughout the end or middle of your season. So then you're not running into problems like, oh, this person said they wanted to be a part of the team, but they're not putting in their full effort. Well, maybe it's because there's circumstances that, if you would have talked about at the beginning of the season, are really affecting that commitment level. So talk about and understand each other's priorities and circumstances to prevent complications later down the road. The next thing that I really think is important is be respectful to each member no matter what their role is on the team. I can't tell you how many times I have seen this within teams I've been a part of. I've seen this from the outside of other teams, but I don't care if it is the 7th grade rookie or the 12th grade senior on the team who has been in their program in FIRST their entire lives. Everybody needs to be treated equally. That is literally what FIRST is built on. Being able to help each other no matter what your level is and going down and mentoring younger people or reaching up and learning from people that are more experienced than you. That is what FIRST is. So with that, be respectful of each other. You're going to be stronger if you're respectful to each other. And it is so disheartening to see when that isn't a value on teams. So please, coaches, mentors, students, leaders, make that a priority and pass it on to other teams. The last thing is treat each other equally, whether rookie, veteran, and coach. And this is the same as respect, okay? I think a lot of teams like to value the titles and value the roles and all that, but if you stray away from treating each other equally, you're going to lose that unity within your team, and it's going to become a little bit more dispersed, and that's going to be complicated to handle from anybody's point. A captain's going to have trouble leading his or her team if everybody doesn't feel like they're on the same level and the same unity. Sorry, my cat's running around. If you hear like running and scratching in the background, just try to ignore that. Treating each other equally, right. So find ways to include and respect and bring each other up and treat each other equally, and also treat your parents and coaches and mentors respectfully and equally. Everybody that is around your team and in the community of supporting your team only wants to help you guys, right? So be thankful for those people that are helping you, be kind, be respectful, because those people you might have reached out to them or they might have reached out to you, but it should be a mutual beneficial relationship where there is respect and a treatment that is equal. And again, that's a really big value of FIRST. So all those values, all those things we just talked about, factor into your team dynamics and how you're going to use all those things to prioritize team dynamics, right? If you really pay attention to all these specific details and all these different points, you're going to be more successful as a team, you're going to be more unified, and you're going to be more cohesive as a team throughout your season. All right, with all that being said, let's kind of talk about the foundations for your team and the foundations for your dynamics. To start off this section, have you ever heard the saying, there's no I in team? And then have somebody in the conversation followed it up with, but there is a me. Let's apply that here. So basically, these are all the things that I think team relationships and foundations on the team should be built on. But they only work if everybody on the team is thinking about them and applying them. So there's no I in team, yes, but there is a me. And as you are the me, what can you do to apply these things? How can you be aware of these things and actively using them to strengthen your team? Let's start with fun. Don't throw fun to the edge of the table. Keep it as a priority, because if you don't have fun on your team, it's going to be really hard for people to want to keep coming back and working hard, okay? Fun needs to be a priority. It needs to be right next to gracious professionalism and productivity and brainstorming and innovating in the design process. Fun needs to be up there, because that way your relationships are going to be organic and real, and the judges and the tournaments, that's where it's going to shine through. It's going to shine through for those people. So keep it fun, keep it fresh, keep it gnarly. The next thing your relationship foundation should be built on is encouragement. The season can be tough. Everyone's going to go through challenges. Everyone individually is going to go through struggles and hurdles in their own sections or in their own lives. So remember to be encouraging of each other. And don't be quick to say things like, oh, you don't have your work done or you haven't done your responsibilities. But be encouraging and helpful in that way. And be positive. Be encouraging and be positive. The next thing is rewrapping. Back to respect. Be respectful. This will be very important to the strength of your team throughout your season. Starting with respect will lead to other greater things that will be beneficial for your team. The next thing I think is important is shared values. This comes in with figuring out what your team priorities and goals are at the beginning of your season. What things do you guys all have in common that you want to strive for? What things can you bond over that make you guys more passionate about robotics? Your shared values could include certain outreach activities to different communities. Maybe a group of you guys is really passionate about doing STEM outreach to puppies. Great! That's a shared value that you guys can bond over and work together on and make it something prioritized on your team, and it'll be really cool. If everybody on the team is separated and boxed off into their own area and you don't have anything to work together on or bond over just out of enjoyment and being passionate about it, there's no way your team is going to grow. But if you can find areas that you all share and like and enjoy, it's going to be more fun and easier to do those projects and do those things and those tasks in a way that you all are encouraging of each other and you share those things. That's the whole reason you're in robotics together. You all enjoy FTC. It's now figuring out what parts of FTC do you all enjoy and can bond over and make super powerful and become a powerhouse team based on those things. The next thing is being supportive of your members and supporting each other and lifting each other up and not being quick to put each other down. This is something that I should be giving advice to all teenagers. Be supportive of each other. Be kind. Be nice, especially in our world today. Put everybody up. Put people up. Be kind. Say a nice thing. You know, I'm a senior now. This is my last year in robotics. And I was raised by a lot of veteran teams and by a lot of students that were older than me on other teams, and I probably wouldn't be here 5 years later still competing if those people weren't supportive to me and would have put me up. So, in a way, pass that on. I'm passing it on to you guys, and I hope you guys can take this and pass it on to other people, because this is something really important to me, putting other people up. The next thing I want to talk about is understanding of each other. You can't have strong relationships and strong team dynamics if you're not understanding of each other. And we kind of already talked about that. But again, understanding why things are happening on your team, understanding where people are coming from, and then being able to move forward. Don't take everything as it seems or at what it looks like. Take a minute to have conversations about problems, have conversations about why things are happening. And then that understanding will provide solutions that might not have been seen before that. The next thing is teamwork, working together through problems, working together through tasks, working together on projects. That teamwork will lead to stronger relationships and stronger, more cohesive team dynamics. Then the last thing that I think is really important is trust on a team. Having trust that each person is passionate about robotics and passionate for each other, it's kind of an interesting thing, being able to trust your team members. Being able to trust that your relationships will prevail through challenges and disagreements. Trusting each other that when somebody has an idea that you might not have thought of, that'll actually work and be super cool. Trusting each other in a way that if somebody has an outreach idea that sounds insane, that maybe if you just gave them a couple words of encouragement or helped them brainstorm on their ideas, that you could come up with something really cool. And having that trust in the team will be so strong and put your team so far ahead of other teams that most people won't even stand a chance against those people, because their trust will make them stronger in their projects, in their presentations, in their robot performance, and it will make every area of their team stronger. So those are the foundations that I think need to be prioritized and need to be put above everything else to make your team dynamic stronger, which happens to be the next thing we're actually going to talk about. 20 minutes in, we're finally going to talk about team dynamics. Trust me, what I wanted to say before was important, but now we're getting to the meat of it. Let's go. Team dynamics. 3, 2, 1, action. Okay, so on a team, to be successful, there's going to be a lot of work. There are lots of tasks to do in FTC. FTC, in the robotics world, is certainly more challenging than VEX, because in FTC there really are so many things to do. So, a solution that people have come up with? Sub-teams. It's really not that complicated, guys. Sub-teams are just where general areas of the robotics team are divided up into smaller sub-teams. And that is an important key for your team dynamic. If your team is struggling to get work done and struggling to distribute tasks and have certain members focus on the success of areas in your teams, well then you need sub-teams. Even for me, when we have 4 people on a team, we technically still have sub-teams where certain people work on certain areas, okay? Oh my gosh, my cat's attacking me. Okay, so sub-teams are successful and helpful for your team dynamic because it helps resolve stress when you have so many things to do. I believe that every member, new or old, should be exposed to all areas of FTC. Okay, I'm saying this really cheesy, but I mean it. And should not be cornered into one specific role the entire season, okay? I see when a new person or old person joins robotics, they're exploring STEM. They're exploring real world things, okay? So if that person gets cornered into, like, photography, maybe that person would have actually been passionate about programming. Or maybe if somebody gets cornered into CADing or cornered into building, maybe they would have been more interested in writing technical documents and getting into marketing and other departments. So I really think it's important that teams should be careful to not just corner people into specific roles because that's what the team needs, but find ways to allow people to figure out what they enjoy, figure out what they're passionate about, and then break off into sub-teams. The major benefits to subteams is that a small group of people are focused on one particular area of the team, and this allows for people to be focused and prioritized and really devote the majority of their energy into time into one area and making it the best they can. When team members are distracted and dispersed and don't really have something they can focus on, it's hard for that area to really be built up and made stronger, as opposed to certain people that are really focused and devoted to that area and they learn to become passionate about it. But these subteams that you create within your team should be decided at the beginning of your season. Mostly before kickoff, hopefully. Because then when you get into the season, when you get into the run of the mill and you get into all the tasks that you have to start doing, you can funnel those off into their groups of people quickly and you don't have to spend time figuring out who's going to be responsible for what. The second point is subteams should be less boxy and more like a Venn diagram. What I mean by this is subteams does not mean these certain people only work on this. That is not the definition of subteams in FTC. Subteams just mean that certain people are focused and devoted to one area, but they're also included in the other areas of robotics. I think that everybody on a team should be involved to some degree greater than 0 in all the areas of FTC. Everybody should be learning about each other's role and should have some understanding of what other people are doing on the team, so then they kind of know the bigger picture beyond their little world of what they could be responsible for. Okay, so like a Venn diagram, not boxes. Stop thinking boxy, start thinking circles, okay, people? Overlapping circles. I mean, I guess you could have overlapping boxes. Anyways. Optional sub-teams include robot sub-teams for building, programming, or CADing. Those can be certain sub-teams that people are split off into. You can have notebook sub-team. Then the business section or business sub-team, those people are responsible for relations in the community and the budget and all those expenses, and outreach. The dynamic between these subsystems really depends on what these groups need from each other and what they require from each other. So the robot team will need to have strong communications with the notebook team to make sure their design processes and everything that they're working on is getting documented properly. The business team has to have good communication with the outreach team to talk about professionals in the community and how they're going to get supports, like from sponsors and from people that are going to help them. And all the sub-teams need to work together and be cohesive and have strong communication so they know that everyone's on the same pace and working together. Most importantly, during tournaments, when you're preparing for tournaments, all the sub-teams need to be communicating to make sure you're all getting ready at the same pace and you'll be prepared for the tournament in all areas. Alright, let's talk individual roles. So the benefits of having individual roles for each person on a team is that they really feel important and valued on the team. They feel like that they are unique on their team and that they have a very specific role that contributes to the overall success, and they feel a certain importance of being there, that they are an important piece of the team identity. Especially for rookies and new kids that are joining, being able to give something to them that they are responsible for, that they have ownership of, is very empowering and makes them very excited and passionate to learn more about that. So individual roles, to kind of further define that, it's more like these people are responsible for overseeing these areas. They might have an individual role title, but they don't actually do all the work for that aspect. They're just responsible for making sure that in that area the work is getting done, right? So somebody's individual role on a team might be they overlook notebook meeting entries, okay? They're responsible for making sure that the entries are getting done, they're in the correct templates, and they're getting put into the notebook. They're not responsible for getting the actual content or tasks done. They're responsible for making sure it's getting done. And this individual role description can be applicable to all sorts of areas. You can have a build team captain, who's responsible for making sure the building's getting done. You can have somebody responsible for taking pictures at outreach events. You can have somebody responsible for the budget and the business section. There can be individual roles if you have 15 people on a team or if you have 5 people on a team. Everybody can have an individual role to any degree, minimal or large. I think this is also very applicable to rookies. Don't just give them a role at the beginning of the season. Really allow them to explore the different roles and aspects of FTC teams, and then allow them to choose a role that fits them and what excites them. Allow them to find something that they're really interested in so they want to stay on the team. And then for not just rookies, for anybody, for coming back every year, allow team members to find roles that suit them. Overall, this will lead to greater retention on your team. A quick example of this is, imagine a rookie that only takes meeting notes in scouts tournaments. They might have a different experience compared to a rookie that has the freedom to explore and find their passion in FTC. The rookie that gets to explore and try new things might find something that really attracts them and makes them want to come back year after year after year. If you just give something to a rookie that they might not be interested in, the chances of them coming back are lower because they might not feel like what they are doing was something they actually wanted to do. It was something they felt like they had to do. So in that way, help people find what they like to do on the team and help them pursue it. Okay, let's talk about team captains in FTC. First of all, what does a good team captain look like? I think that a good team captain is, first off, very organized. They have the ability to oversee and manage multiple areas on the FTC team and really be able to see everything from a pretty decent bird's eye view and manage the timeline of lots of activities that are going on at once. A team captain is also very respectful of all the members on the team, and they are kind to members that are younger than them, members that are older than them. They're respectful to coaches and mentors, and are a good role model for the other people on the team. They also have the ability to value the team over themselves. They see that their team captain position doesn't really put them above their team members in any other way except for overseeing and responsibilities. Otherwise, they're on the same level as their team members. This is also something that can be viewed differently from team to team, but personally, I think that a team captain that really values their position as not a title or a name to be plastered on their shoulder. It should be something that they take responsibly, and then they see that gives them a position to lead other people and not put themselves above others. I think that a good team captain is big picture oriented. They establish their goals based on their tournaments, and they see the long-term projection of what they're working on and not just in the now. They have the ability to really see how the tasks that they are completing build on each other and lead to overall goals and not just one thing at a time. And finally, I think a good team captain communicates well with members and coaches. They have the ability to stand up for the team and discuss broad level conversations with the coaches. They can really be the spokesperson for the team on opinions and attitudes, and really communicate their thoughts and feelings of a team to the coaches and mentors, but can also facilitate those feelings within the team and allow the team to collaborate and work together well. And they have the ability to establish strong communication between team members and between coaches. Finally, this is what warrants the title Becca's Hot Take on Captains. Do I think all teams need captains? My personal opinion is no. I do not think that FTC teams, to be successful, need a, air quotes, captain. And from my experience in FTC, I was actually never on a team that had a team captain. Or at least I say that. When I was on Next Gen for 3 years in Minnesota, and on that team, I was very responsible for overseeing lots of tasks, making sure everyone was doing their thing. I was very heavily focused on the notebook and the outreach, and I was involved in the robot side, but I had a lot of responsibilities for making sure everything was getting done. And under my own definition, that would have made me the team captain. But I never liked saying I was the captain. I never really liked saying that I was the captain. It was an uncomfortable title for me to hold because my peers on the team were the same level, putting in the same commitment, doing the equal amount of work as I was, but for some reason I didn't feel like I warranted the title team captain. I didn't feel like I should have be able to put myself above my team members like that, but I still embodied the values of a team captain. So, do I think all FTC teams need a, air quotes, team captain? I don't. Do I think all teams need a person or a couple individuals that are responsible for overseeing all of the activities on the team and are responsible for making sure things are getting done? Yes, I do think that. So, take that all as how you decide to do team captains. If you are a high school team with 15 students, a team captain will probably be a wise strategic choice for your team, just because that person can help facilitate and organize all the things that are happening within your team. If you are on a team of 5 or 6 people or 4 people, a team captain, if you're all working together and you're all being responsible and you have some people that are overseeing and making sure things are getting done, I don't think you need to air quote team captain because you're all responsible for those things. So take your position as a team, evaluate your status, and see what you need. If you need the title team captain for people to respect that role and pay attention to it, then yes, have a team captain. But there are other ways to adhere those responsibilities and those roles on the team than just saying team captain. Moving on, now I'm going to talk about how to facilitate team meetings in a way that encourages and promotes strong team dynamics. Team dynamics, I believe, include strong collaboration and teamwork and working together, but I think there are also things that you can do to make your team dynamics work stronger and more effectively. So, next to that, I would start all meetings by begin together, establish goals and priorities, and then break apart. I think a strong team meeting, a nice general strong team meeting, starts with everybody coming together and getting on the same page. Whether you're meeting around the table or on a Zoom call, you're getting all the team members together so you're all communicating and regrouping and recentering before beginning your tasks. And then after you kind of do that, you can be broken apart or you can separate to work on your own goals and projects. I also believe that meetings don't have to include everybody. If I'm being honest, for me, the people that were on my team, I was really good friends with. So when we were meeting all together, it was really hard to be productive because we would often get distracted by just having a good time and hanging out with each other. So I found that as an individual in my sub-teams, I was most productive when I was separated from the whole group with just my sub-team focusing on what we had to do. So, from a coach's standpoint, how can you encourage your team to start together, collaborate on goals and priorities, and then break off and get your work done? That can help with making sure tasks are actually getting done during meetings and you're not just hanging out and having a fun time the whole time, okay? Lastly, for how to facilitate strong team meetings while being aware of your team dynamics, is that teams should be separated to focus on their own work. This isn't to be rude and separate friends, this is just to make sure your teams are breaking up responsibly and making sure that they're getting their work done. But also in a way that they're still with each other in a general same space so they can collaborate and share if they need to, and still be a team. I don't know about you, but for me, I do not like conflict, drama, or arguments. Those are typically things I try to avoid in my FTC teams and in my experiences. So for this next part of the presentation, I'm going to be walking through how to resolve different conflicts and share from experiences, share from what I've learned, see if I can offer any advice to any teams that may be going through this, and just kind of share any advice that I have from this certain area and strategies I have for overcoming these conflicts. So the first one that is on here is disagreements between two people. From an internal perspective, if you are one of these two people, the best way to get over a disagreement is to just talk to them, sit down with the person, and talk it out one-on-one, and really listen to the other person. If you're having an argument with somebody on your FTC team, you're probably disagreeing on something or your ideas aren't lining up. It's probably not that all of a sudden you've decided that they are the worst teammate on the planet and you want to kick them off the team. There are steps we can take before reaching that point, which include communication. Really try to understand where the other person is coming from, and hopefully they will also take that approach, and you can see where you're both coming from and hopefully compromise or find a middle ground. For somebody that's on the outside of these two people that are in a disagreement, try and talk to them one-on-one and see, okay, what's happening? How can I help you? And then if it really seems like the two people can't solve it on their own, try and intervene and become the person that can help them communicate to each other and help them resolve their conflict. Because if this is left alone, it can just keep growing and growing and becoming bigger and bigger of a problem, and eventually lead to what I said before, hopefully not, but realizing that you guys just aren't clicking and it could be a problem. The next thing I see here is disagreements between sub-teams. This can be big fat drama llama if not taken care of seriously. I see this, the biggest example there, the clearest example that comes to mind, or that is probably most common, is when you have a notebook team that's trying to get entries done and you have other sub-teams that aren't willing to document. That's probably the most stereotypical occurrence of disagreements between sub-teams, because maybe the robot sub-team or the Irish sub-team doesn't want to document what they are doing. This sort of disagreement can only be resolved again through strong communication. If the sub-teams aren't working together and listening to each other's needs, the team dynamic is going to fall apart because you aren't able to help each other and aid each other in the things that you need to support each other in. That'll make you stronger. Disagreements between sub-teams, if large enough, can also cause problems where coaches need to intervene and really be able to oversee on a larger level what's happening. When the sub-teams get large enough, it's hard to see from an individual what you can do on the team, and you might want to reach out to a coach to see if they can help you solve it. And if it gets big enough, get the whole team down. Sit everybody down and just talk about it and really work through it and not just let it be, because it's probably an issue if multiple people are rather upset about it. The next one is what to do when multiple people are losing motivation. This is something that I've experienced with team members before. This is something that I've had other people ask me about on other teams for advice. And it's something that I think a lot of teams experience once they reach that third or fourth year with people that have been there for a while. When people start losing motivation, I think the first step is to recap and go back and ask those questions that you asked at the beginning of the season. Ask about their circumstances. Ask about their goals and their values and their priorities. Ask about their circumstances, because if those things are changing for that individual throughout the season, then their motivation for the team is changing too. And if this person is if they're like a junior in high school and they're becoming very stressed by school and their diving team is becoming an overcommitment for them and robotics is starting to slip, they might be losing motivation because they're just too stressed and they can't handle it. One way to solve this is to reassess that person's commitment and what they need from the team. Because if the team isn't helping them, they're not going to help the team back, and they're going to start to lose that connection between the motivation to do robotics and their responsibilities. Because if they don't have the motivation, they're not going to want to do their responsibilities. And if they're only doing their responsibilities to keep up on their tasks, they're going to lose motivation. It's a two-way street. So when an individual on a team starts to lose motivation, attempt to reassess their circumstances and what their goals and values are. And hopefully by doing that, they can see where they are in the team and kind of regroup for themselves and get them back on track to be more motivated and to hop back into the game and become interested again. If they're losing motivation because the tasks that they're doing aren't interested enough, reassess what they're doing on the team. Maybe they got stuck on a responsibility or job or area on the team that they're not really excited about, and help them reassess and find a different area on the team that they might be more excited about and more passionate for. The next thing is to do, and this is more of an individual issue, is what to do when it feels like you are doing all of the work and pulling the team. I think this is experienced by people who have been the core of a team for a very long time, and they're kind of losing members here and there over the years, and you find yourself being the last person really passionate about the team, and you find that you're having to do a lot of work to keep everybody going. And at this point, I would say you have two options. Your first option is to get the team together and talk about what your competitive level is and what your goals are. If the overall team's goals and competitive level do not align with yours, you have to see if you being on that team is the best thing for yourself. Maybe at that point, would be a good option for you maybe to find another team or find another environment that supports your passion and your motivation. Just because you've been on a team for a very long time doesn't mean that you can't adjust or make changes for yourself that are better for you. You need to be responsible for putting yourself in an environment that you know that you will grow in and be happy in, right? So if it feels like you're at a point where you're exhausted because you're doing all the work and you're pulling your team and you just can't get everybody on the same level you are on, that's going to be an issue that you can only solve, and you can't get other people to change for you in that way. And then your second option to be for that is to maybe lower your expectations a little bit and become a little bit more relaxed. Because if you have your bar set a little bit too high and your team is consistently maybe landing below that and it's more frustrating for you, try and see the season from a different perspective and maybe realign your goals and expectations, and maybe find the fun of the season and the team interactions to be the part that are filling you up. And then that way you might have a better season going for you. This next one is a little bit difficult, but I do have quite a bit of experience with it. So, what to do when you get in a disagreement with a coach? This one's a bit tricky. When it comes to the team against the coach dynamic, that can be difficult to navigate, especially as your team ages throughout the years. I think that when it comes down to what does the team need and what does the coach expect? From a base level, there needs to be respect no matter what. The team needs to respect the coach, and the coach needs to respect the students. Even though the students are kids, FIRST very much is built on the fact that kids are treated as respected thinkers and innovators in our world. And if a coach doesn't see that in them and the students don't feel respected, that relationship is going to have a lot of turmoil, and it's going to be difficult for the coach and students to trust each other. But anyways, when you get in a disagreement with a coach, that can be a little bit of a sticky situation, and it can cause other problems down the road if you aren't able to resolve those conflicts and disagreements as they come. If it becomes a disagreement where it's very much the team against the coach, or it's very much the team's side is different than the coach's, and it's not like some students and a coach against other students, then I think it should come down to the students and what they really think is best for the team. If it's a robot design idea or a notebook concept or anything that's very much tournament based and competition based and can be flexible. If it comes down to something that is very much based on logistics and based on the safety of the team and those areas, that has to go to the coach, and it has to be a responsibility of the coach overall. I think, again, also, when it comes to a conflict with your coach, if you have multiple coaches or multiple mentors, discuss this disagreement with them too, and see if those coaches can reach out and talk to each other. I know that if teams only have one coach, that can be difficult, but if you can reach out to any other parents or adults that are working with your team, maybe they can help collaborate with your coach and solve that disagreement. Alright, next is how to resolve conflicts at tournaments. This one is definitely something that you learn as you go, and you have to figure out what works best for your team. For me, I've competed on 2 teams in my career, no, 3 teams. 1 team from FLL and 2 in FTC, and I found that at tournaments, if there's an argument or a disagreement or there's a conflict, the best thing that team members can do is take some space. Take a 5-minute break, just walk away, take a breather, drink some water, eat food, definitely eat a snack. Just take a break, take a breather, relax, and then come back. Because tournaments are very high stress energy situations, and that when you conflicts and disagreements appear much larger and much more chaotic. And so if you ever have a disagreement at a tournament or a conflict, just take a step back, breathe, relax, and then try and figure it out and solve it. That's my best advice for that one. To resolve conflicts at meetings, again, take some space, but then sit down and really talk about it and really work through it and not just be upset at each other and not talk to each other. Work through it. Take the time to struggle through the conflict, figure it out, and then come to a resolution or compromise. If there's a conflict at an outreach event, if there's an argument between members, or is there something happening within the team at an outreach event, you need to drop it. You cannot have that around your team when you're presenting FIRST or STEM to the community. That is a bad image that you're putting out there, and you need to be careful that you're not depicting FTC or FIRST in that way. So be very careful that if you have any conflicts or arguments at outreach events, try and table them for the time being and then bring them up later, and not make the outreach event the time to solve your biggest problems. Alright, next. Last but not least, we have reached the end of our presentation, and we are going to be recapping and kind of applying what we've talked about so far to what do team dynamics look like in other settings in different groups. Let's start with team meetings. At your team meetings, team dynamic should be very collaborative, based on having fun and having encouragement and respect for each other. You should be able to work in sub-teams and be focused on your own individual work, but also be able to bond over things that you share and have shared values. There'll be individual roles that inspire people to become passionate in their certain line of work, and everyone's overseeing and making sure tasks are getting done. The team dynamic around professionals should be very well put together. You should be very respectful of each other and put each other up and not down. You should be kind to your professionals that you're working with. You should seem interested and be polite and be very energetic around them and show them that you care about what they're talking about. The last big one I want to tackle before I sign off for the evening is coaches and team dynamics. This one can get a little bit dicey and rather controversial, but I'm graduating in like 6 months, so does it really matter? Okay, the coach's role, let's talk about coaches from a 5-year experienced person. The coach's role in the team is to guide and lead and help the students learn in a way that's not intrusive or overwhelming, right? The coach is there to help the students learn and explore and become passionate about robotics, but not give them all the answers along the way. Help them solve problems, but not give them the answers, right? So the coach's role is very supplementary and helpful, but also the coach knows when to step back, right? So let's talk about what coaches do to help our teams. So our coaches help us gather resources, they help us solve problems, they help us resolve conflicts. They're great at that. They are essential for organizing the logistics, signing our teams up for tournaments, and making sure we're all there. So we have a lot to thank them for, and they're there for a lot of reasons. But also, that role can change, right? So can the coach's role change over time? And In my experience, yes, the coach's role does change over time, especially when the team members remain the same over the years and it's not specifically a high school team, but it's more of a neighborhood team that remains consistent over time. The coach's role can evolve. Maybe a rookie season, the coach is rather involved in helping the students learn about FTC. They're still understanding, okay, how does this work? What is the engineering notebook? What is an FTC robot? While everyone's trying to grasp what FTC is, the coach is extremely essential because they're essentially guiding and teaching the students what FIRST is. But there comes a point where the team becomes able to work and evolve by themselves, and they can start working as a little company, as their own team, and they don't need an adult walking with their hand, holding their hand through everything, right? So in my experience, the coach's role does evolve and it changes, and this can be difficult for a coach. And the best way to deal with that is through communication and talking with the coach and reassessing their role over the years, and not just abruptly flipping a switch on them and changing the dynamic. Try and transition that with communication. To get into more specifics, coaches during meetings can help with time management. They can make sure that you aren't spending 2 hours playing Rocket League just as your icebreaker, okay? They can help facilitate that time management. They can make sure that when you split up into subgroups, everybody is in somewhere that they want to be, and they can help make sure tasks are getting done. They can also resolve conflict. Coaches during outreach events can be very helpful for making sure students are getting where they're supposed to be at the right times. They can help establish communication sometimes in that way. And then coaches during tournaments. This is a long conversation, and if any team wants to know more about what my experiences were and what I've learned over the years, or hear my advice on this, coaches during the tournaments, yeah, that's definitely the point where they kind of have to let the bird fly from the nest. That's very much the time where the coach needs to step back and say, I've helped you along this far, now it's your turn to show everybody what you got, okay? The coach really needs to take a moment to step back and let the team do what they've been practicing and building for months, okay? I always recommend to second or third year teams, have the coach stay out of your pit. The coach does not need to be in your pit the entire day unless they're hurting children, okay? Yeah. Hurting children. The coach should never touch the robot, and the coach should really avoid any sort of direct interaction with mechanical parts, poster boards, things, the pit setup, everything. They just try to be hands-off as much, coaches, so the judges really see that the team is self-functioning and they've really gotten to a point where they can be independent and separate from their coaches at that point. And that's really all I have to say about team dynamics in other settings and other groups. That concludes our presentation today, guys. I just want to say thank you so much for watching and listening in today on our presentation on team dynamics. A huge thank you to RevAmped Robotics for hosting WorldShop. I love participating in this event. I think it's so cool what they are doing. Again, we are Team 6369 the Designers. If you want to partner with us or reach out, just send us a message on Instagram. Our account is designers.6369, and our email is ftc6369.designers@gmail.com. I will say we are much more likely to respond to our Instagram than our email, so if you want to reach out or message us, shoot us a message. We would love to meet you guys. We'd love you to talk. And yeah, that concludes our presentation. My name is Rebecca. Send us a thing if you have questions, and I hope you have a great day. See you later.
Welcome back, everyone. I hope you all took away some useful tips and enjoyed that presentation by Dynamics on the Designosaurs. Our next topic is drivetrain control by Revamped Robotics from Oregon, USA. As always, feel free to be putting your questions in the chat. And without further ado, I'll hand it over to them.
Hello everyone, my name is Kyle Zhou and I'm the lead programmer on 12808 Revamped Robotics, and today I will be talking all about drivetrain control. I'll be going over the main methods and our experience with movement algorithms over the past couple of years, and hopefully you'll learn something useful that you can apply to your own robot. So first of all, what do we want to achieve when we drive from point A to point B? Well, first, we want to be able to drive with accuracy and consistency. And so for this season, maybe this means that we want to cycle between the Alliance shipping hub to the warehouse multiple times without hitting the barrier and scoring the freight on the shipping hub. Second, in order to cut down on travel time, we need to find the most efficient path, allowing us to save travel time and ultimately score more game elements. And third, we want the robot to travel at the highest possible velocity and acceleration without straining your mechanical systems. And so in the next few slides, I'll talk about how we can achieve these goals. So you might ask, driving from point A to point B, how hard can it be? Well, the most intuitive method is to just set your motor power for time. Anyone who has tried this knows that you'll never be at the same position twice. And this is because there's a lot of variables that we're not accounting for, such as battery voltage, wear on the wheels, and field imperfections. Now, another way is by using bang-bang control. It uses just drive encoders and calculates the error to the goal position. So the main gist of bang-bang is to drive at full speed while the error is positive, stop when it is 0, and then drive at full speed in reverse when the error is negative. But we can all tell that this won't be accurate. It'll get you there fast, but it won't be accurate. There's almost 100% chance that you'll overshoot and you'll have to oscillate for a long time. An example of this is if you're 0.1 inches away from the goal, you'll still be going full speed, so you'll definitely overshoot the target. So before we get into more complicated algorithms, I first want to go over odometry. So to design an efficient autonomous, the biggest problem is the inherent drift on mechanism wheels, and therefore the motor encoders are inaccurate. So the goal is to provide an accurate external measurement of position and then use this system to move with accuracy and precision. So there's many different ways to design an odometry system, and our team uses 3 linear spring tensioned E4T encoders so that they're grounded to the field. I know there's other designs out there. One in particular is open odometry by Primitive Data. I know that one's pretty popular. But with this odometry system, we also have the advantage of other sensors, such as the IMU, that can give us the heading. So with these sensors, we can now know our local position and heading, and this works when you only face one direction. So if you're moving straight or diagonal, as long as you're facing one direction, your localization will be accurate. However, this becomes a problem when you turn because your coordinate axes change. So to solve this, we can use rotational matrices to convert our local coordinates to our global coordinates. So on this diagram to the left, the red axis is our local coordinates and the blue is our global coordinates. So this is an example of going from global to local, but it also works the other way around. So to find, this is our goal position right now. And so to find the delta x for the local coordinates, we can find this distance and then subtract it by this distance. So this distance is, we can find it by using theta and then the delta x for the global coordinates. And then for this distance, we can derive it from this right triangle where we can take the sine of the theta and then we can also use delta y from the global coordinates. Then to find the local coordinates y, we can find this distance, which is just using sine for this angle and then the delta x for the global coordinates, and then add it onto this distance, which is from the second triangle. And so from that, we can get these two equations. And to go from local to global, we can just input the delta x and the delta y here, as well as the theta. And then we can just simply solve this system of equations to get the global x and y. And so the shortened version is this equation right here, where at every sampling point, you would just update your current position by adding the newly traveled distance to your previous x and y. Okay, a better way to drive from point A to point B is to use a PID controller, which is widely used in industrial control systems and FTC in general. It stands for proportional, integral, and derivative, and is similar to Bang Bang, but it tries to solve the problem of oscillation by setting power proportional to the error to the target. So I know a lot of you have probably heard about PID controller, but just to give a quick recap, the proportional values are exactly what it means. It's proportional to the error. So it'll start off big and get smaller and smaller as it approaches the target. The integral term is used to overcome friction. So when your error becomes extremely small, the proportional value won't be enough to overcome friction, and so your robot is just stuck there. So the integral sums up your error over time. So if you have that small error for a while, it'll add up and set more power to the motors. And finally, the derivative term attempts to dampen the rate of change as a result tries to remove oscillations from the controller. So the code for a PID is very basic, but the main art in PID is tuning the values. And the table right here shows you how you might go about tuning the values based on the results that you get. So for instance, increasing P will decrease the rise time, but it'll increase the overshoot. And increasing D will decrease the overshoot, which makes sense because that is the main use for a D gain. Now, in addition, FTC lib, which is originally an FRC library, has now been redesigned for FTC, and it has many useful resources, including a PID implementation, where you only have to plug in the PID values, and it already has the PID implemented for you. So now there are two main problems that can happen with a PID. One is integral windup, and integral windup happens when the integral saturates the system. An example of this is if you hold on to your robot as it tries to move to the end goal. This will cause the integral sum to increase as the error doesn't change over time. And then when you release the robot, the integral sum is so large that it overpowers the rest of the values, causing the robot to overshoot until the integral sum drops low enough for the system to regain control. So we can solve this by adding a limit to how big the integral sum can be. This allows the integral sum to actually make a difference, but not so much to cause windup. Another problem is derivative amplification. This can be caused when the D gain is too high, creating an unstable feedback loop that causes oscillations to increase. So for this, you just have to watch how big your D gain is so that it doesn't cause this problem. So the pros and cons of a PID is that, well, the pros are that it's simple and it allows you to drive accurately because it adjusts to external variables such as voltage. However, the cons is that there's drastic changes in voltage because once you set a new target position, the error spikes. And so it causes your robot to accelerate instantaneously. So this causes strain on your mechanical systems. And another con is that tuning is not fun. So if any of you have tuned a PID, you'll know this. So the next algorithm is pure pursuit. You want to use pure pursuit when instead of rigid movements, you want to drive in a curve in order to travel less distance. And so this allows you to follow multiple waypoints at certain headings in a smooth fashion. A popular way to do it is by creating an imaginary circle around your robot and following every intersection between the circle and your path. The robot continues to follow the intersection in real time, and it's essentially a P controller for the heading that has the robot move at the fastest possible speed around some path. Now you can either implement a custom Pure Pursuit, which is what we did, but I believe that FTC Lib has now come out with its own Pure Pursuit package that you can use on your own robot. Another great resource is Gluten Free's Pure Pursuit series on their YouTube channel, and that can help you begin to write your own custom algorithm. So next, I'll show you a video from the Gluten Free Pure Pursuit series. And so it just shows you how the Pure Pursuit algorithm rounds out these rigid edges to give you these smooth driving patterns. And then next up, I'll show you how we used Pure Pursuit during our ultimate goal season. Okay, so just to give a quick overview of how the Pure Pursuit algorithm works, I'll go through some gluten-free code that we also used on our robot last season. Now, it's important to know that the intersections between the path and the robot are determined by two base equations. The first equation for it is a circle, which is x squared plus y squared equals r squared. And the second is just a linear line, or your path, which is y equals mx plus b. And so we can find the intersection of the equations by setting the equations equal to each other. And based on the diagram to the right, you can see how there may be more than one intersection. And so this is why we need to filter out different which intersection to follow. So on the diagram, we see that we can have two, and it seems like it's even possible to have three. And so now the code below here shows the process of filtering out these points. So after you set the equations equal to each other, you have an array list of intersections, and then you just go through every single intersection and you find the angle between the intersection and your robot by using tangent. Then by using the difference between your current angle and the calculated angle, we can update which intersection we want to follow as the angle that's closest to our current angle. So based on this diagram, we can see that this algorithm works because the angle here is definitely closer to our current heading than the angle here is to our current heading. Now, another issue we had with our Pure Pursuit algorithm was that at the end of the path, our algorithm ran out of a look-ahead point. So basically, this radius circle just ran off the path. And so this caused a bug in our code. And to solve this, we just used a PID when our distance to the last point was within a certain limit. All right, so next I'll be going over the pros and cons of Pure Pursuit. Some pros about Pure Pursuit is that the code is simpler than more complicated strategies. In addition, it adjusts well to disturbances because of the P controller. However, it does have some downsides. First, unlike motion profiles, which I'll go over later, it has no control of velocity or acceleration. And also, when following tight turns, it's pretty often that it'll skip over some sections depending on your look-ahead quality, position, and path. And so now I'll show you a video of how the Pure Pursuit adjusts to disturbances. Yeah, so you can just see how it's basically a PID controller adjusting the robot back after it's being pushed around. Now, I said before that Pure Pursuit has no velocity or acceleration control, so how do we control our speed? This is where feed forward or motion profiles come in. A motion profile is a different way of looking at this problem compared to a PID approach, and it uses the characteristics of a robot such as maximum velocity and acceleration to create a profile that will smoothly accelerate to the max velocity and then decelerate to the goal. So by using this approach, you know exactly where your system should be at all times, so it's easy to tell if something went wrong. Also, as the motion profile shows, the velocity graph is continuous, meaning that your motors aren't thrashing back and forth. So this is easy on your drive motors. Now, usually in FTC, we use trapezoidal motion profiles, which is just accelerating, cruising, and then decelerating. It's also important to notice the difference between trajectories and paths. So as you can see here, paths are just waypoints, and this is what Pure Pursuit uses. However, trajectories are waypoints, but each waypoint has a time and a velocity and a position. And so that's mainly the purpose of what motion profiles and trajectories do. Okay, so next up is feed forward and feedback. So feed forward controls what you plan ahead of time without the use of sensors. For instance, you'll know that at 1 second, my robot's supposed to be going 20 inches per second. Feedback is like PID, where you use sensors to measure the difference from the expected state of motion. Now, there are two main important terms in feed forward control. The first is KV. So KV is the coefficient between real world velocities and motor speeds. For instance, if your maximum velocity is 40 inches per second, then your KV should be 1 over 40. So then your motor power would be 1 when you're driving at the maximum velocity. The next is KA, which is basically the same as KV, but instead for acceleration. It'll add a little extra power to accelerate and then decrease to decelerate. So the next is feedback. The feed forward is supposed to do most of the heavy lifting, but the feedback is there to pick up after any slop or any deviation from the planned state. So once you have your motion profile, at every set point along the path, you must know your velocity and acceleration is supposed to be. So from there, it's just a basic PD controller that you have to tune. So the benefit of this approach is that instead of immediately looking at the end goal, the PD controller only has to trace this moving target. And the error isn't large, which means that there's less oscillations than a regular PID controller. A PID controller will spike, causing the robot to go full speed, which is rough on the robot, and it causes overshoot, which wastes time. So you can see in the example code right here how the overall feed forward works. So you have your KV constant and your KA constant, and you multiply that by your velocity and your set point acceleration. Then you have the basics of a PD controller, which is just your error, and then your error derivative, which is just your error minus your last error over time. And then you just add those into the system. Now, so now we know how to follow a trajectory, but how do we generate it? And so this is where the Roadrunner library comes in handy. It allows you to characterize your robot, tune constants, and most importantly, generate trajectories and motion profiles based on the paths or trajectories that you create. The library does give a warning on the complexity of the libraries, especially for beginning users, because without the general intuition of the system, debugging is nearly impossible. And so far, we've had some success by using Roadrunners to facilitate our trajectory generation and following. One useful resource that I'll go over is the Learn Roadrunner page that will take you step by step through the process of tuning your robot. All right, so now I'll be going over the tuning process for the Roadrunner library. The drive constants file includes everything regarding the physical characteristics of the robot, and this includes the motor's maximum RPM and the wheel radius, etc. Then you'll have to configure your dead wheels, and then after that, you'll have the localization test, which is driving your robot around and seeing if there's any discrepancies in your localization. And then next up is the drive feed forward tuner. And so I'll give a quick example of tuning your feed forward. So basically, it's just tuning your KV and your KA values, like I've talked about before. So first, start off with KV. So we can hardly notice any changes. So if we slightly increase it, we can see that our velocity jumps up, and then a little more. And there we can see our maximum velocity matches pretty well with the target velocity. And so that's the whole point of KV, is to match the conversion of the velocity between the two. And then we'll start on KA. And now you can see that our acceleration fits tighter with the motion profile. And that looks about good to me. So that's basically the tuning part for the drive feed forward tuner. Now the next step is the straight test, which just determines how effective your feed forward tuning turned out. And then finally, you'll have the follower PID tuner, which you'll have to tune the two PIDs, which is basically closing the feedback loop. And so this enables to ensure accurate path following. So this is just picking up after any slop that your feed forward tuner doesn't pick up. And then after that, you'll have the spline test, which just tests how well your robot can track a spline. And then after that, everything is just about writing your own trajectories to carry out the tasks that you want the robot to carry out. So one helpful tool that can be used for all the algorithms that I've talked about is FTC Dashboard. So FTC Dashboard is a web app for monitoring robots, and it allows you to print telemetry with plots and graphics, as well as live configure variables. So for instance, one way you could use it is to tune PID constants and graph the error to see the results of your constants without deploying code all the time. In addition, you can tune your feed forward constants and even see your robot on the field. It's also super convenient if you don't have your driver station and still want to be able to run code. So FTC Dashboard is also a standalone library, so you don't have to use Roadrunner to reap the benefits of this library. So an example of adding your own variables to a live tune is by just adding this @config at the top of the class and then just making your variables public static. And so here's an example of what FTC Dashboard would look like. You would have your field here, you could have your graphs that you want, and then your live variables that you want to tune. And so at the end of all of this, this is what our team came up with. So we're able to cycle, using Roadrunner, we're able to cycle 3 flight currently. And so here's a quick video of how we've done. Okay, so that's all I have for today. Here are just some extra resources that may be helpful for you to look at. We also have our contact info and our website. So if you have any questions, feel free to send us an email. But other than that, thank you for listening.
Welcome back, everyone. I hope you all learned from that detailed presentation on drivetrain control by FTC Team Revamped Robotics. Our next topic is outreach, presented by Team Zio from Alba Iulia, Romania. As always, feel free to be putting your questions in the chat. Now, I'll hand it over to them.
Hello everyone, we are Team Xeo from Romania. I am Diana and this is my teammate.
Andrei.
And today we are here to talk about outreach. First of all, we would like to thank Team Revamped for inviting us to take part in their event and giving us the opportunity to participate again this year. And we will first start to talk about what we do, who we are, and then we'll get on to outreach.
So, first thing first, Xeo started about five years ago.
Almost
This
6.
year will make 6. And it all started when a couple high school students found out about FTC and went straight to their teacher and said, we want to make a team. We need to participate in this competition. We like it and we would like to make robots. And in a matter of like couple months,
I think so.
the team already started making robots and started getting good at making this. And sadly, the first year was a bit more harsh, but then it continued to be way more better. The name, it's actually a funny story.
It's a very funny story.
The name came from a license plate, and it was, I think, the license plate was AB01 Xeo.
Yes, so one of the team founders' father had a car, and the license plate said Xeo, and they thought, hey, why not make that our team name?
It's catchy.
Yeah, it's very catchy.
And
It's
it doesn't have a lot of letters.
exactly. But later we found out that in Latin it means something innovative, so it also has a very beautiful meaning.
Yes, the name the name is funny, but it connected us.
Yes.
Xeo now means a family. We became a family because in the course of 5 years we have more than 100 members in the team and alumni.
Yes, we have had very many members, and it just shows that by working together we became a family and being close. For example, we are still very close with our alumni, and we still have a couple projects with them.
The team is divided in 5 departments: 3D modeling, mechanics, design and public relations, and programming, the brain of the robot.
Yes. So so as you can see, we have technical and non-technical departments, and even if FTC and robotics sound like it's just something like nerdy or only programming and mechanics, it's so much more than that. And ever since the team has been founded, Team Xeo has always been very involved in outreach.
What is really outreach?
So outreach in FTC is about promoting the first core values: discovery, innovation, impact, inclusion, teamwork, and fun. And it's also about getting involved in the local community and bringing innovative ideas and bringing creativity to the community to try to improve it.
We had some big events.
Some really
big events, national events that were made in the last 3-4 years.
Yeah, something like that. We have a few events that are a tradition in our team, and we try to stick to them every year. Even in the pandemic, we try to make the best of everything we have, and yeah.
First one, Xeo Talks, which is really the most important event in our team, and all the teams in Romania know about this event. It all started in 2017 when we invited FTC teams in Alba Iulia, our city, and we also invited some speakers to tell us about their job or what brings them motivation, because we need motivation every day. And slowly XO Talks became and not really became but changed. This year we split in teams.
Switched it up a little bit.
Yes, we switched and went to București, Iași, Cluj, and Timișoara, which are the biggest cities in Romania.
Yes, and we started this thing, so we could not bring teams to our city anymore because of the pandemic, and so we wanted to switch it up and go live. So we went over to the teams' hometowns, and interviewed them and played games with them.
We also streamed that event on YouTube.
Yeah. So Andrei, would you tell us more about how it was being on the road? I wasn't there.
I went to Iași, which is about 600 kilometers from here, or 400 to 600, and it was very fun because you get to meet a lot of people, different people with different mindsets, and something unites us. The FTC, the competition unites us, and it's very it's sensational.
It's an indescribable feeling.
You can't describe this feeling with words, so it's very hard to say what happened there.
As it is in the FTC competition, it's a feeling that's very hard to describe for two people who weren't there and didn't feel it. For us, it was a little bit more complicated. We joined the team right when the pandemic started, and we didn't get to go to a physical competition yet, but we felt the rush, the adrenaline of FTC even remotely. Why don't we talk about more how XO Talks was organized and how we I don't know.
Yes. We split in teams of about 3 or 2 members. One was the interviewer, and the other one was the technical man, we say. He made the connections to Alba Iulia, and
made sure everything went right on the technical side. And the third person was the person who would say how basically kept everyone on schedule and communicated through the phone and through text messages while everything was developing, so to say, and just made sure everything was right.
Also was the photographer. A lot of pictures were made, and we're happy.
Memories were made, teams were met, and for this we basically reached out to other teams in our country, and
about 20 teams.
Yeah,
it was a pretty big event.
Yes, it was a pretty big event, and we got to meet a lot of new people and interesting people, beautiful people.
Which made us pretty proud about us and the connections we were able to make.
Exactly. So when it comes to an event as big as this, physical or remote, what were the steps? Let's talk about the steps that were made and how long it took us to plan it.
like
Exactly.
2 or 3 months we had to plan this.
Yeah.
We wrote messages to teams. We made sure that we have a place to stay and where should the interview happen.
Yes, so this was more of the when we had already settled on what we were going to do, but SEO Talks was last month, and this month or last month?
Last month.
Last month, yeah, it's February. And it was last month, and we started planning it in summer, the actual event. But then it went through many changes, as a big event does. And we got
Firstly,
here.
we scheduled SEO Talks for the last weekend of October.
Yes, the last weekend of October,
But,
as it always was.
The pandemic said no.
Yeah, and actually, the first idea we had for SEO Talks 2021 was for it to be a physical event. We had actually already started calling people and inviting speakers to the conferences, but it couldn't have happened because of the conditions.
This year was a bit hard.
Yeah.
Last 2 years, actually.
Hard and stressful. Especially on the events part. The outreach part is pretty difficult when we know that the easiest way to reach people is by talking to them face to face and gathering a lot of people in the same place, but we cannot do that. So it was a challenge for us, but we are very happy we made it happen through the internet.
Yes, but we also did remote events.
Yes,
The edition of SEO Talks from the last year, the last year was made online.
Yeah.
So we can do that too.
Mm-hmm. So how about we talk about the technical part? I know you were on that for Excel Talks this year. It was a bit of a hassle, not gonna lie, and we had to have microphones in every place. We had to have lights and make
stable
sure
connection. That was the most important thing.
And that our stream didn't suddenly stop while we were filming. Not that it didn't happen, but we prevented it as much as we could.
It happened a couple times.
Yeah. No, I was there. I was at home, and we were all sitting in front of like 3 monitors. And suddenly the stream just stopped and the screen turned black, and we were just like, okay, so no more internet for us. Yeah, it was a little bit of a panic moment. We sure had 3 full days.
So it was hard for the people that went to the cities, because when the stream stopped, we didn't know what to do. We just typed on our keyboards and talked to the man who was here at home and said, man, what do I do, man? What?
Yeah, it was a big moment of confusion. We had like 3 phone calls going on at the same time. Like, what do we do? Somebody was late to go to a place, others didn't have internet, or I don't know. So what did you do to prepare on the technical part with the gadgets?
The whole setup consists in a microphone, a phone, ring light, and that's it. But the preparation took about, I don't know, 10 minutes, 5 minutes, and to get the people placed, like us right here. But it wasn't really something hard. It was just, I don't know just how to say it, but something simple, straightforward, and we were all having all types of emotions. We were scared, we were shocked, and stress. Yeah, a lot of stress right there.
But it was worth it, wasn't it? Very worth
Definitely.
it. Okay. That's it on the technical part. Now for the actual organization and the lists that we made, we had a few. We've always, for every event, we have a checklist with many items, may I say. that with then things that we have to do before an event. Now I am a part of the design department and also work on PR. I'd like to start with the promotional materials. We always have to have promotional materials for every event. For every single thing that we had at XEO Talks a few
Stickers.
TV stickers, yes, and TV shows, as we like to call them, and we had to make animations, which...
Do you think those were important?
Sorry?
Do you think those were important?
Yeah, they were a little bit important for the image of the event, but more important than the promotional materials and everything for that we had to, post on social media and stuff, was the actual collaboration and communication in the team. Because at the start, it was pretty difficult to find... we were about 20-30 people when you first started planning XEO Talks. And as you know, people sometimes leave the team because they think it's not suitable for them, and we had to make lots of changes and even last minute changes 2 days before leaving to a city. Somebody couldn't make it anymore, and we had to be able to communicate this between us and not have any conflicts, because that's what a team, what a family does.
They help each other and to not happen, to prevent bad things.
Yes. So so for preventing bad stuff from happening, the deadlines, we always put the deadlines a few days before the actual deadline, so that we have a little bit room for
errors, to find errors and communicate with our members and say, this is not good, please make it again.
Exactly. Or if, I don't know, something breaks, or...
Which happens way more often than you think.
Yeah, I wouldn't think this stuff breaks a lot. I think we had the ring light that had the broken screw, and we put a screw from our robot pieces from our toolkit. We fixed the ring light, and okay. Stuff like that happens, and it's alright. And
how stressed you were in that period?
Well, it's very stressful. I had design deadlines and lots of stuff to do, so yeah. And here at home, it was pretty stressful. We were running around and trying to get to people, so maybe in a few cities, or maybe they didn't have any phone signal, and we tried to reach them, but we couldn't. And we panicked because at one point, I think the stream didn't have any sound, I think, and they were just talking and the stream was going, but...
Yes, no, actually, we had no video, but
sorry.
But it was sound. It was no video, but it was sound. It's like a podcast.
Yeah. So they were just talking, and no, there was no video. It was, I don't know. At the end, it's a very nice experience, and just to sit back and watch what we made, we're very proud of it.
Actually, one of our big events, not really event, was the fundraising. We also did a couple of fundraisings in December, and we tried to make them pretty often because it connects us with the community, because you need to connect with the FTC teams, but as a team, you also need to connect with the community. The first fundraising was this summer at a local museum, and we brought our field and robots and let people play with the robots.
Yeah, problems in this. The robots sometimes didn't work.
Yes, it doesn't. Sometimes.
And the people enjoyed it very much. Keep going. What
we also had 2 robots based on Arduino, and we made a football field, a mini football field, and the little kids really liked that because football field, and You want to play
So
football?
the robots were controlled by phone, and a few days before that, we had painted this big table that we made. We painted it to look like a football field, which later was transformed into an ice rink for, robot ice skating.
We also had an arcade.
Yes, that's a very great part. Tell us more about the arcade, and I know it had to be fixed.
It had to, but no, the people really liked it. We liked it
Yeah.
because it brought the 80s to us, and it was just
It had like thousands of games and hundreds of games on it.
yes.
And it was a really big hit, to say the least. And we had all these attractions, and we were set up outside and inside of the museum. It was very hot outside. We were there from morning to until the 9 p.m. We were there all day, and we also, to promote this event, some of us stood there and at the stand and with the kids and the people and talked, and some of us also went around the city and handed out flyers to promote our event.
And when people came to our stand, we also gave them some 3D printed figures.
Yeah, I think we had the 3D print. No, didn't hear what you said. Sorry. Yeah, so we had 3D printed figurines. And
The kids really liked it. They were like, "Yo, this is an airplane."
So about organizing the fundraiser, we always have meetings before organizing an outreach event. And about organizing the fundraiser, again, promotional materials, people who handed out flyers, people who were at the stand, the technical department who was there for tech support, of course, when maybe the batteries didn't work, or I know we ran around for batteries. So that's a great tip. You always have to be prepared with
Batteries.
batteries, with backup stuff. We had to bring big external phone batteries, like those portable ones, and duct tape them to the robots.
They worked a little bit.
But it was not very good, as they stayed out in the sun all day.
Yes.
And then it rained.
And when it rained, we had to take all those and the arcade and the football field and bring them all in the museum. And people were staring at us because they didn't know why are students making this, and why the children are running with football fields and an arcade.
Exactly. Why are they running around carrying robots? What's going on? What's wrong with them? So that's another thing why these outreach events are very important, especially this fundraising. This fundraising was for the families affected by the floods in the Apusen Mountains. And we actually did very well in this fundraising and were able to donate the money. So these are very important, especially for helping our community and building a relationship with the community, and also for letting people know that not only do we participate in competitions, but we also want to get involved in the community and help.
We really like getting involved in community.
Yes.
We also went to schools to
Talk about
teach.
the other fundraising first. We had another one.
The other fundraising was made at I think in the first week of December.
Yeah, I think so.
It was in the commercial space,
Yeah, it was at the mall.
and we also brought the field and the robot stands with stickers and emblems, and again the people really liked it.
The the 3D printer. You also brought it?
Yes,
Yeah.
we also brought the 3D printer.
Big attraction. The 3D printer was right there on our table, and little kids who were like, so the 3D printer was like here, and they were like over here, and they were always like looking up at it and seeing what it was doing, and they were very fascinated by it. And we see this as a way to let people know and to what we do, and to see if other kids from younger generations find their passion in what we do and maybe want to continue on this path.
Yes, that event, that fundraising went really good.
Yeah,
Also.
we let the kids. We had the field there, the robot field, and we had the 2 robots. Only one was used, and we let the kids play with them. We had controllers, and we let the kids take the robot and use the intake and outtake systems to take game elements off the floor and play with them. And we also had a microphone,
Yes.
remember?
Yeah.
Tell me about it. And it was like we had this big speaker, I think, and we took the microphone and took turns speaking on the microphone and announced in the whole mall, and everyone like came around the field and looked and saw that the kids were playing, and we were like, hey, who's gonna be the next driver? We need a new driver for the robot. And we encourage kids to play with the robot because it's very important for them to.
It's fun. It's entertaining.
It's
That's the
fun.
most important thing too.
Exactly, and I think it's also a good experience for them because everyone when they're kids is usually obsessed with robots. I also liked robots.
In union with the community, we also went to schools to
Schools from our city.
to let the kids know there is a robotics team in our city, and it's really fun, and to promote this because
Promote our activities.
yes.
Yeah, so what we did there more exactly was we prepared a presentation, right? Can you tell me about, did you go? And I think you also went to a school.
Oh yes, we made a PowerPoint presentation about what is FTC, what our team does, and how usual season goes. We talk about the competition, the phases of the competition, and as I've seen, the kids really liked it. We also brought the robot and let them play with it.
We just take the robot everywhere. It's our child. We are proud parents of a robot, as our stickers say. I think the kids were really passionate about it, and some of them had already heard of us and had questions. And we also brought the engineering notebook. No, we brought more notebooks. We have it here. This is the one from our regional, and I think it's very important for the outreach events. We also had them at fundraisings if people wanted to know more about us and wanted to know more about what we do and why we do it. So this was Excel Caravan, and it's a pretty big event in our local with our local community. And we get to speak with a lot of people and even meet our old teachers from when we were in the grades 5-8.
Yes,
Yeah.
which is heartwarming.
It was very heartwarming. So it's not always about the it's not always about the competition. It's also about being close with your community and bringing creative new ideas,
And making friends.
and gathering a family.
Yes, a bigger family.
A bigger family, yes. Okay.
We also did a we named it XO Olympics because it had three three
like not stages, three parts. It was it's like the Olympics. Everyone had a category.
The first one was Capture the Flag, which included which made the people solve some programs and solve problems. Yes.
So this was the programming competition. They had to find things in a code.
Some little secrets about in the code and how to solve it, and they got points, and who was first in that stage competition got a keyboard, I think.
Yeah, so we had different prizes for this, and in this event FTC teams could participate.
Actually, everyone could participate.
So we even had people who weren't involved in the first community to participate. We also had, I think, people from FLL teams.
Yes.
Yeah. Very passionate people. And everyone had a place in it because there were two more
categories. It was the 3D category, and the people made I think it was to make a car, and people were really creative in this category.
So we even had like war cars, like cars were upgraded for going to battle. The 3D modeling part was a very...
We even seen a car that had a grill inside, so...
That's a great car. That's a big upgrade, I don't know.
The perfect car.
It's a perfect car. It's great. And
also the startup category, but the people who wanted to make a company, I think it was.
Yeah, so you had to make a startup, come up the business idea, and present it to the judges. We were not the judges. We had people from those specific domains judge the teams. And the startup company, you had to come up with an idea and present it and make a business plan for it. So for the people who are passionate about that, it's very great. Yeah. How long?
This
was the competition?
This was a 24-hour event. It started in the evening of Friday and ended in the evening of Saturday. But the Capture the Flag category ended like in the morning of Sunday because the first two teams were very close, and we said, okay, there is 1,000 points difference between you, and let's make another challenge for you, and who solves it first will get the prize, the big prize. Which we were really shocked to see that two teams were at 1,000 points
so our
difference.
Scoring system was...
It broke a few times.
Yeah. The scoring system was very wild, to say the least, and the teams tried really hard, and I know because we had a Discord server where everyone was to organize and keep things under control. And that's where everyone was, and they were talking in the Capture the Flag chat, and it was like 11 a.m. the second day, so these people hadn't slept in like 30 hours, and they were just working continuously. And I was very worried for them.
When we made the Discord server and invited the people, all like I think 75% of them had questions about Capture the Flag. What is Capture the Flag? What we have to do, and what we get for being the first team. They I don't know if I was more stressed than them, but
Yeah.
we still don't even know.
So the programmers of our team, to put it like this, they were at this very table in the same spot at like 3 a.m. in the morning, and they were very stressed because something
Answering
went wrong.
questions.
Yeah, and they were answering questions, and some were fixing problems, and it was all a very energetic thing. Like, we didn't really sleep that night, but it's fine.
It was fun.
Yeah, it was very fun.
For us and the people.
Yeah.
It was
So how
fun.
this worked was the server. We had channels for every team to go to and roles, and we organized it all, and we stayed there.
Yes, and when the teams didn't have any questions, we just stayed in a help channel, voice channel.
We had a help channel and took turns. Because I don't know, I think we took turns sleeping a little. So you can see this goes. You have to be very passionate and to put a lot of effort. Very much effort goes into these outreach events. And as long as you do them and you have fun and you work in a team,
that's what really matters. To have fun.
All that really matters. And as long as you do them with the purpose you have in your heart, I guess, it's really great, and it's a very enjoyable experience. And
let's also talk about the association.
Okay, so
because it had some really big achievements. The first project they made.
Wait, let's talk about what it is first.
What it is, yes.
So, what is? I'll go.
The Excel Association was actually made by alumni.
So they wanted to continue the Excel story after graduating high school.
And it really helped us, the team, and they are making really big projects, and they are gaining recognition in this community.
So the Excel Association is a non-governmental association. It's an NGO, and it had a few important projects up until now. It hasn't been around for a very long time, but it's very important to us, and this is how we keep in touch with the alumni. We make projects like this. So one of them, and the one that I think was had a very high reach, to say so, and many people saw it, was La Pictura. Basically,
that's the picture.
The picture, yeah, and it's in the center of the city.
It's a painting on the wall of
a very tall building. You can see it from everywhere.
And the painting was made with paint that clears, purifies the air.
Yeah, it was made by a pretty famous artist, like street artist something, and it's made with paint that purifies the air, and it has, I think, 100 square meters. Yeah.
Something like that.
The picture represents Mother Nature. So
we also started a challenge in this. The people from our cities, or if you come to Alba Iulia and you take a picture in front of the picture
and put hashtag La Pictura,
we posted on our Instagram account.
We encouraged people to come and take pictures and see what it's all about. Yeah.
It also participated in a project named Robots and Doctors, which they made a robot to take the food and deliver it to patients in hospitals.
Yeah, so the doctors
to eliminate the people, because
the middleman.
Yes, the middleman.
So doctors could bring medicine and food to patients in the pandemic without coming into contact with the actual patients. So it's more safe that way.
Yes, it reduces the.
Yeah, I remember I wasn't in the team at the time, and I saw that and I thought it was genius. I thought it was very great. We also have Educația X Education, which was a project that we participated in, that we know, well, that association organized, and they 3D printed educational materials like for biology class, like anatomy, and for physics for schools in smaller villages, I think. No, around our
The
country.
villages around the city.
Yeah.
And I think the most important project we have, it's going now.
Yeah, it's ongoing. It just started.
It's named Relief, which helps the local harvesters and the local shops to gain attention
Yeah, to be more
and
involved in the community.
yes. We also do this by going to near villages, buying their products, honey, apples.
Yeah, and promoting local producers because it's very important to shop local. And it's Relief is a project that is very important in the domain of ecology. And the first thing, it has more phases, and the first phase that we started with was
Planting trees.
Planting trees, yeah. So a bunch of people from the city and whoever wanted to volunteer.
Even the other team from our high school, XO
Yeah,
Academy,
exactly.
which is in first Lego League.
Yeah. They went and planted a bunch of trees and took photos and started the project well.
It was a big start.
It's a big start, a great start, and we can't wait to see what's next.
We also teamed up with association Biciclim, which promotes riding with bicycle in the town, and this summer, I think, or this spring, from what I understood, we are going to have bicycle trips with the people from our city and promote.
Exactly, to
Bicycle
promote
going.
riding the bicycle and a more eco-friendly way of transport. So what you can see here and what we presented were our just a few of our outreach projects. And if it's something, if there is something we want to say for the teams who are just starting and for the teams who are wondering what outreach is all about and why it's important, we have a few tips and tricks, so like a few points. First of all, it's very important to keep in mind that you have to care about what you are doing and always do it with a purpose. Like, be passionate about it, you know.
That's what really matters.
Yeah.
To be passionate and to be heart and soul, heart and body in that.
Because the things that have the most impact on people are the things that you do with your heart. Yeah, and it's very important to have fun. Yeah. The most important thing. And by that, in the FTC community, you promote, and outside of it, we promote FTC values like that. Also, a very important thing with this is to organize and to be organized, to always keep a list of what you want, of what you have to do, always communicate. And
Bring people together.
yeah, bring people together. Always remember what your purpose is in this, and we guarantee that your event will go perfectly from there. Even if some things go wrong, you have to think about why you're doing it and how much it matters to you. Because if it matters to you, then you're gonna do a great job.
And you will be satisfied by
Exactly.
the event or
Exactly, because that's important. That's what's important, to communicate with the local community, to encourage people to get involved in improving and creating and innovating. Yeah.
And thank you for inviting us to your event.
Yes, we want to thank you very much, Team Revamped, for inviting us to your event this year.
And we want to participate in the coming years as well.
We're looking forward to anything more.
To cooperate.
To collaborate. And thank you very much for having us remotely. And yeah.
Goodbye.
Bye.
Welcome back, everyone. I hope you took away some useful tips on how to conduct some effective outreaches. Next, we'll be taking an hour break, and we'll resume at 2:15 p.m. Eastern or 11:15 a.m. Pacific Standard Time. So, we'll see you guys then. Welcome back, everyone. Let's continue the second part of our WorldShop International FTC Conference. We'll be first joined by Suffern Robotics from New York, USA, who will be presenting on mechanical design. As always, feel free to be putting your questions in the chat. Now, I'll hand it over to them.
Hello, so I'm Jordan Siegel, the captain of Suffern Robotics, and today we're going to be talking about how to master the mechanical aspect of your team. So this just involves everything like physically building your robot. If you have any questions, you could feel free to email outreach@suffernrobotics.org, or you can reach us on social media at Suffern Robotics. So just a quick introduction to our team. So we've been a team for over 15 years, and in those years, we've been to the World Championships 5 times. And so far in this season, we have won the Design Award and came in second place for the Inspire Award and have advanced to our regional championships. And last season, we also advanced to our regional championships by winning the Think Award and coming in second place for the Inspire Award. And so we kind of know what we're doing a bit. So first, I'm just going to talk about the importance of mechanical and just everything it provides for your team, because it has a lot of benefits that you might not realize. So the most obvious is that it allows you to have a working robot. Mechanical, as I said earlier, involves all physical elements involved in building and assembling a working robot. So having a strong mechanical team and a strong mechanical force allows you to have a working robot, which is kind of one of the most important parts of robotics. And it's also necessary for all aspects of a competition. While you could technically still advance without having a working robot through awards, having a robot that works, or at least attempts to work, is super important to judges because it at least shows you're making an effort. And I mean, it's robotics, so it's nice to have a robot. And it's also, we're a robotics team, so building a working robot is what a lot of people come for. So doing that is super impressive and stuff, and is also a goal for many of your team members. So another important thing that mechanical leads to is winning competitions. As you guys probably know, competitions aren't solely about having a good robot, but in order to win the top awards, a good robot is often needed. And additionally, having a strong robot allows your team to increase your chances of advancement by allowing your team to perform better in matches. Well, there's a lot of variables that go into match play, such as your teammates and if anything breaks or Wi-Fi issues, etc. Having a good robot just increases your chances for things to go well. And even if stuff goes wrong and you don't get to pick and you're not an alliance captain, having a good robot will still increases your chances of being picked for an alliance team, a final alliance team. And one of the most important parts, at least for our team, is sponsorships. While many sponsors might not know specific details about robots and first, they do know what to look for. And so having a good robot, even if it just means it's able to move around quickly and it's able to pick up blocks or whatever and do a fun demonstration, many sponsors find that to be super engaging, and they like seeing that you're making physical progress and are actually building a robot. And while, again, some sponsors might not need or want to see it, it could still be a huge selling point, and it could lead to outreach events, even where you're meeting with sponsors and saying, hey, thank you so much for your sponsorship. Here's how your money or goods or mentorship have helped us build this robot. So it's really important for sponsorships as well. And as I mentioned a bit earlier, outreach events. Now that COVID is starting to die down a bit, community events are starting to come back up, and having a good working robot is super important for these kind of events. Many people find seeing a robot impressive, even if it doesn't necessarily work. They just like seeing a robot, and it kind of just shows, yeah, we're able to build this. And if you feel comfortable allowing kids and even sometimes adults to drive your robot, is super fun. A lot of times they love it, and it's really engaging. And this is just a great way to connect with your community, to advertise your team, and you can even collect donations and stuff like that. So having a good robot is important for more than just the competition. And finally, one of the, in my opinion, most important parts of focusing on mechanical is that it helps you prepare for the future. So working mechanically and just with building stuff is super important for many jobs in the future. And even if you aren't going to go into something mechanical, it's also just super good to know how to be able to repair stuff just for around the house and just in general. So it's super good. And additionally, it also helps to keep your team sustained. Mechanical, as I've mentioned, is one of the most important parts of a team. And so having new members and just everyone really work on mechanical, you're helping to ensure that your team is able to be sustained for years to come. And so it's really important. And now I'm just going to talk about the mechanical process because it can seem a little overwhelming. I mean, it's pretty much everything to do with building, so it's a lot, but I'm going to try to break it down. So our team uses the engineering design process when just building our robot. So it's used mainly when just trying to solve any problem. As you guys can see, it's like a circle, and I'll kind of get into that a bit more later, but it just pretty much provides the steps of how to go through and solve a problem. And so I'm just going to break down how we do that. So first step is brainstorming, and I'm sure a lot of you guys do this already. So the first part is to just brainstorm different possible solutions. So our team likes to do this by getting around a whiteboard and just sketching out different ideas we might have. And one of the other things we also do during this kind of phase in our design process is to discuss different priorities for our season. So, for example, this year we talked about whether or not we wanted to go over the barrier or around the barrier. In prior seasons, we talked about what type of wheels we wanted to use. So, this is just really kind of setting up the building blocks for your season and ensuring that you have a good foundation and good kind of basis for all your ideas. And brainstorming is one of those things that kind of happens as you go, but having like a good solid brainstorming session with your entire team at the beginning of the season allows everyone to be on the same page for your general kind of ideas going forward. Next is prototyping. So after brainstorming, we like to make prototypes of some of our ideas. And prototypes are just kind of quickly built versions of our designs so we could test ideas without having to spend a lot of time or use a lot of materials to actually test these ideas. This allows us to just, again, test ideas to make sure they work the way we want to before we spend months and lots of time and materials on an idea and then have it actually not work. Again, prototyping is one of those things we kind of do a lot throughout the season. So as our ideas fluctuate, we'll often build a quick prototype to test new versions and make sure it works the way we want it to. After prototyping and kind of coming up with our favorite concepts, we like to use a 3D modeling program in order to design our robot beforehand. We use Fusion 360, but there's also many other programs out there. Like I know teams who use SolidWorks. I know some teams who use Blender. So it's really just about finding what software works best for you. We like Fusion because it is cloud-based, and we're also able to get free accounts just because we're students. But again, it's just about finding what software works best for you. So using a 3D modeling program, this ensures that our entire robot will basically be able to do what we want it to do, and we won't have to struggle to fit stuff in later or have stuff that doesn't fit. And it allows us basically to ensure that everything we want will be on the robot. And it also is really nice because it's kind of like instructions for when building your robot. It's like using like a Lego guide because you're just copying what you see, what has already been made. And it's also good because it helps to provide documentation for future years. So there's been many times where there's a design that we've used in the past few years and we're able to just go back and look at it and be able to alter it to fit our design. It helps you to avoid reinventing the wheels. And again, it's just something that's good for maintaining your team's legacy. So after fully designing our robot in CAD, we begin to fabricate or basically build the parts we need for a robot. So this is pretty much done if your team decides to use custom parts for your robot. So we like to use custom parts because it allows us to do stuff with that might not be available otherwise. I'll talk about that a bit more detail, but we make these pieces typically out of metal, and we use just common hand tools such as a bandsaw or a drill press in order to get the desired shape and sizes. After the completion of our individual components through fabrication, and just purchasing parts, we begin combining everything together into different subassemblies and then larger subassemblies. Working in smaller subassemblies has been super helpful for our team because it allows us to kind of have different people working congruently, and then we could just combine everything at the end. So this allows us to maximize our time. And it's also helpful because if, let's just say, one part of your robot doesn't work or part of it breaks, you don't have to disassemble the entire thing. You could just take off that one part that doesn't work. So, and then we also do assembly at kind of the same time. So we'll have someone working on the chassis, and then once someone finishes, like, let's just say the intake, they'll put it on the chassis while someone is still working on the output. So this kind of helps us be super efficient and, again, is really useful. So after completing different parts of our robot or the entire robot, we like to test things along the way just to make sure everything works the way we want it to. Testing along the way just allows us right then and there to know if our idea needs to be improved. This way, again, as I mentioned earlier, you're not sitting there with a completed robot that doesn't work and you have to go back and kind of redesign everything. And also testing along the way allows us to look at these parts and see, hey, is there anything we could change quickly to make it work, or do we have to fix this entire idea? So again, this is just a way to be efficient and ensure that later down the line, things work the way you want it to. And then, as I mentioned earlier, we just kind of repeat the process. So a large portion of the design process is just repetition in order to get the best possible results. So even if the robot is finished, there are often things that could still be optimized. And even if there isn't something obvious or something possible that you could do to make your robot better, there's still stuff you could do, such as practice with autonomous and driver practice. So there's no real end for robotics, and I'm sure some of you guys already know that, but that's just something to keep in mind. And now, as I mentioned earlier, there's a lot of different methods to building and fabrication, and it could be a little overwhelming, so I'm going to try to break them down. So while not necessarily building, 3D printing is super important, and a lot of teams utilize it. So sometimes it could be easier to design a specific part in CAD that could be 3D printed to accomplish a specific task that a part might not be sold for. So for example, our team needed these super specific brackets that weren't really in any size. And so instead of trying to make brackets ourselves out of metal and stuff, we just made them with our 3D printer. And this allows us to, again, accomplish a task that we wouldn't have been able to solve otherwise. And if you're designing your robot in CAD, or at least parts of it on CAD, it's a lot easier to make 3D printed parts just because you can design them directly on your CAD assemblies. And I know 3D printers are kind of expensive. So if your team doesn't have one, there are many companies that are able to 3D print, and you can even talk to some local companies and see if they'd be willing to sponsor you or give you a discount because you're a robotics team. A lot of times companies are willing to do that if they know that their products are going to go on the robot. But in general, I would recommend if your team has some money, or just saving up for a 3D printer, because it is extremely useful. Next, as I mentioned earlier, fabrication. So this is a way just to build custom parts for your robot with tools and other materials that are often readily available. Our team uses metal and just other like hand tools such as a bandsaw. We use a sander and stuff like that. So like with 3D printing, this allows your team to have access to parts that are probably not sold on the market, or if they are, this just allows your team to kind of have customization of them to complete a specific purpose. So we've made certain panels that wouldn't otherwise be available. And so even if you are using a build kit, which I will get into earlier, fabrication is crucial to ensuring that your robot is able to complete the tasks you want it to. Next is CNCing or machining. So, like the other options mentioned before, using a CNC allows your team to create custom parts otherwise not available. So for those of you who may not know, a CNC is kind of what I like to call a reverse 3D printer. So a 3D printer works by building up plastic layer by layer to get the end design. A CNC works the opposite. So you start with a piece of metal and then cut away in order to get your final result. So CNCs can be very expensive and require a lot of training in order to use them. So if your team wants to use custom metal parts, as you can see in the image there, or like in the past, our team has made custom chassis, you could use a CNC and try to save up for one, or there are often many companies that will offer CNC or laser machining as a service. And again, similar to 3D printing, if you mention that you're a robotics team and say, hey, this would be our robot, they'll oftentimes maybe give you a sponsorship or a discount. So CNCing is definitely something that is super awesome if you're able to do it, but also if you can't, don't worry about it. I just wanted to cover it just in case people were curious. So now pre-built kits. Most teams are probably familiar with these. So these are kits which come with pre-made channels and other parts with holes that all kind of fit together that allow you to arrange them however you want in order to create kind of a basic frame, chassis, etc. It's kind of similar to like Lego, if that makes sense. These kits are extremely useful for both rookie and veteran teams. For rookie teams, when you don't have a lot of material starting out, this provides a solid foundation and allows you to kind of use limited resources to build a great robot. And for veteran teams, it's just useful to have these parts lying around to attach to stuff you might already be making. So there are many different build kits out there, and it's important to figure out which one would work best for your team. So Tetrix, which is considered one of the oldest build kits around, Tetrix is primarily uses metric, but it could also be used with some imperial parts if sized correctly and using proper conversions. It also doesn't contain a lot of holes, which can be kind of constricting when building. If you want to alter your design later, you might not have the hole available to do what you would like, so you're either going to have to drill it or figure out placement. So that's definitely a negative thing. But for all our older veteran teams, a lot of us have a lot of Tetrix just lying around because, as I said, it is one of the older build kits. So if you already have it around, it's definitely worth using, especially if you don't have the money to invest in a newer build kit. Next is Actobotics, which is a kit made by Servo City, and this is designed primarily for FTC. Actobotics is Imperial, which can be pretty difficult to, and it is pretty difficult to use any metric parts with it at all, which kind of is annoying because our team primarily uses metric, but it's up to you. As you guys can see, it has a lot more holes than Tetrix, so that makes it more useful right off the bat. And it also has been around for a bit longer than other newer build systems, but it's a bit newer than Tetrix. So, like Tetrix, we also just have a lot of Actobotics lying around. So for veteran teams, again, if you have it, I would recommend using it, especially if you can't afford a newer build system. Next is GoBuilda, which is personally my recommendation, but I'll get a bit more into that later. So GoBuilda is a newer build system. I think it came out a few years ago, which is also made by Servo City, similar to Actobotics, which is Servo City. And it's designed entirely for FTC. The system uses metric, and there are some conversions available to Imperial. Since it's newer, it offers a much sleeker design, and it has, again, many holes, and it has just really good features, especially for FTC teams, where you can place motors inside the channels. That's my personal favorite, to help save space. And it's just overall a much sleeker design. However, like I said, it is newer, so for veteran teams who might have other parts, it's not necessarily worth it to buy this, but if you are a newer team, I would recommend it. Now, which is best for you? There's no correct answer. It really depends on the team. For veteran teams who may have a lot of Actobotics and Tetrix lying around, switching to a build system can be expensive, and it's also difficult because you might need to purchase new tools and new screws, and there's just a lot that goes into switching to a new build system that you might not realize. Our team recently switched to GoBuilda, and along the way there's a lot of stuff that you don't consider, like pieces that you might forget to order, and now you're having to wait a week to get in a new piece that you needed that you forgot to order. So for veteran teams, if you have a lot of Tetrix or you have a lot of Actobotics and you're familiar with it and you're able to make it work, I would recommend maybe just sticking with it unless there's something really specific you want from a newer system, in which case then you could switch. But for teams, Tetrix is able to do the job, Actobotics is able to do the job, so it's really up to you. However, for newer teams, I would recommend going straight to GoBuilda. It is a little expensive, however, I think it's worth it. It's super sleek, and it's just able to accomplish a lot of things that Tetrix and Actobotics can't. And so if you're looking for a new build system to buy right off the bat, GoBuilda is great. And they also provide discounts for FTC teams. So I would recommend that. Next, I'm going to kind of go into managing mechanical. So mechanical is a large part of the team and often has some of the most members dedicated to it. So it's important to know how to manage it properly so things don't get out of control. So this is how our team likes to manage mechanical. So at the top, we have kind of our team captain who manages everything, including mechanical, but isn't directly involved. And then under them, we have our head of fabrication and head of machining. Our head of fabrication kind of manages all the building and assembling parts. So if we're building a custom part, they'll help manage that, or just kind of assembling the robot. They're kind of in charge of that. And our head of machining, on the other hand, focuses more on CNC and that kind of thing. So this isn't necessary if you don't have a CNC or plan on using that or building any custom metal parts. However, our team does have one, so having that is useful. And then these people are in charge of all team members, more specifically all mechanical team members, who kind of report back directly to them, and if they have any questions or issues, stuff like that. So having different steps along the way is really useful because it allows kind of there to be different checks and balances and to make sure that everything gets done, and if there's questions, they get answered. And it ensures that the team is working fluidly and stuff is getting done the way it's supposed to be getting done. Now, our team uses Google Sheets in order to keep track of what everyone on the team does in a day. So if you kind of see, we have the date, and then we have room for the people to write their name and then what they have done. So this allows us to know what a particular person has done on one day, if they finished, what needs to be done, and if there's any photos associated with what they did. This allows us to know what we need to work on future meetings, and it's also super useful when it comes to documentation. And now, team management software. Our team in the past has used team management software, but because we are a school team, we're no longer allowed to use it. But it could be extremely helpful. So there are many free options available, such as Asana, Trello, Monday.com, etc. These are all very useful because it allows the team to keep track of what needs to be done, what has been done, and it allows you to sort into different categories. So you could have sections on mechanical, you could have sections for CAD, and it's really useful and allows you to see visually what needs to be done. So I'm just going to kind of go over some mechanical tricks we've learned throughout the years. Mechanicals can seem like a very overwhelming concept, and it is because it encompasses a lot, but there are many different tricks and tips that we've learned throughout the years that make the process a bit easier. So at the start of our season, we've done workshops, which allow us to kind of ensure that newer members are starting with a baseline level of knowledge. So at the beginning of our season, we spend about a week doing workshops in the 4 main areas of robotics: documentation, CAD programming, and of course, fabrication. So we have all of our new members practice with using basic tools, so cutting different parts out of metal, using the bandsaw, or drilling holes using the drill press. And then we also have them make basic H channels using H chassis using GoBuilda channels. So this allows them to kind of have practice with some of the things we're doing most with mechanical, which is just making parts and building chassis. So once we start prototyping, this is extremely helpful because it allows kind of everyone to have a baseline level of knowledge in the workshop and allow them to kind of feel more confident when it comes to building. During our workshop for fabrication, we also spend time going over workplace safety. So this is extremely important for any mechanical organization as well as a robotics team, sorry. It just makes sure that everyone knows how to be safe and ensures that there's no accidents later down the line. So we went over basic safety information, such as how to properly operate tools, where to find different safety equipment, such as our safety goggles and first aid kits, and just how to be safe in the workshop. So going over this right off the bat allows us to ensure we're safe throughout the year and that there's no major accidents. Another thing we do to help keep our mechanical going strong is we like to do certain cleaning and organization days. So in order to keep our workshop organized and reduce the time we have to spend looking for tools and different parts, we'll regularly have days where we spend time cleaning and organizing the workshop. So we won't have days where everyone just stops what they're doing and organize. We'll have certain members take a break from whatever they're working on and spend some time, not even an entire day, but just making sure that everything is in the right spot and help organize any loose materials and just ensure that everything is easy to find. Again, this just helps improve efficiency because there's been times where we lose a drill bit or we lose a part and then we have to kind of have everyone on the team like, okay, everyone please spend 5 minutes looking for this. When instead of doing that, just along the way, you could take small breaks and just have team members organize stuff as you go along. Now, as I mentioned a few times, mechanical is one of the largest parts and most important parts of any robotics team, so it's really important that everyone gets involved, even if they're not builders. So I'm just going to go over how we do that. So, again, at the beginning of the year, we did workshops. This ensures that everyone has a basic understanding of mechanical concepts. And what we'll also do sometimes is before competitions, we'll kind of say, hey, everyone take a break from what you're doing and we're going to go build this part. We're going to do kind of an assembly line. So certain people will work just on drilling holes, other people will work just on using bandsaws, etc. And so everyone having that kind of basic understanding of mechanical concepts is super crucial to that. Additionally, during competitions, we assign certain people to just focus on repairing the robot between matches or adding stuff. So these people will go, they'll watch the matches, and then if something goes wrong or a part breaks or we just need to add something, etc., they'll be prepared, they'll grab the tools necessary, and once the match is over, they'll start working. It's kind of like a NASCAR pit crew, but during competitions. So again, this just gets everyone in the team involved in the mechanical aspect of robotics. Next, preparing for the future. So next is preparing for failure. So unfortunately, even the best built robots can have failures and parts break, and so it's important to prepare for that. So, as mentioned before, there's many things that can go wrong, and here are just some of the most things that go wrong in my experience as a veteran team. So parts breaking, more specifically 3D printed parts. We used to use just ABA plastic, which is not the strongest, and those can break a lot if you put a lot of pressure. So if you look at the image on the right, that was just a part that snapped. Another thing is parts being made wrong. If you look at the bottom image there, that's a part we attempted to CNC, and if you can see, everything is kind of off. The holes are kind of misaligned. So that's something. And then not having the right parts and not having the right tools, that could really, that's not necessarily something that goes wrong on your end, but it definitely is something that halts progress. And then incorrect measurements, measuring stuff wrong and not finding out you don't fit in the sizing cube, or your part that you designed doesn't fit where you want it to go. So there's a lot of things that can go wrong. And so just how to prepare for that. One of the biggest tips I can give you, if you haven't already been doing this, 3D print extra backup parts. If you can, if you're using 3D printed parts, print more. You never know what part is going to break, and if you're at a competition or you're running matches or you're at an outreach event and that 3D printed part that's controlling your entire output system snaps, you want to be able to replace it. Even if it means you were down for one match because your arm isn't working, you want to be able to get back in, and having the backup parts allows you to be able to do that. And also, if possible, try to make backup parts for high-risk metal parts as well. So for example, in prior years, we had metal parts that our entire robot was hanging off of, and we made backups of that just in case. We were fortunate that nothing ever happened to it, but we know teams who've had metal parts break. So it's just always important to bring backup parts. And again, similar to that, always bring tools when you're traveling. I'll talk a little bit more about what we bring later on, but bringing tools allows you to ensure that if anything goes wrong, you're able to fix it. And now, in order to ensure that things are made correctly, double check your measurements before beginning to build parts. There's the famous expression, measure twice, cut once. So this just saves time later down the line. And if you have decided to CAD out your robot, that is super helpful for ensuring that everything will fit. So you just have to make sure to check those measurements in CAD. And then again, just take your time when building it, taking an extra minute or two to make sure your part is lined up properly and that all your holes are aligned. It will save time later down the line because you won't have to remake those parts. Now, winning awards and competitions. Mechanical is a crucial part of competitions, as I mentioned earlier, and I'm just going to go into how it can kind of lead to winning competitions and awards. So for winning competitions, you kind of need a good robot. One of the most important parts to having a successful robot is consistency, I've noticed. So consistently scoring low points is often more valuable compared to inconsistent teams who go between scoring high and low amounts of points. So even if your robot isn't able to do some of the high scoring tasks, as long as it is able to consistently score a good amount of points, you're often able to make it as either a final alliance captain or even just be picked on a final alliance team. In prior years, what our team has done is focus solely on ensuring our input was good before even making an output system. This way we could have a strong foundation. And while just having an input system isn't super helpful in scoring a lot of points, in earlier competitions in the season, it was actually really useful just having an input system that worked really well because we were able to consistently score a decent amount of points, and that actually allowed us to be a final alliance captain. So it's really just about consistency. Next, creating a good workspace. As I mentioned earlier, having a good workspace and the proper tools is crucial to building and creating a successful robot. So, as I mentioned earlier, organization is crucial to success. Knowing where everything is helps to speed up the building process because it allows builders to quickly find the tools or any parts that they may need. It also helps get the team into good habits, just cleaning up after yourself, putting things back where it belongs, really good habits. So as you can see by the pictures, our team loves labels. We label everything. This just makes everything super easy to find. This way you're not pulling open old jars, like, where's the thing I need? We have just storage cabinets. I think we bought those from Andy Mark, but you could pretty much get them from anywhere, Walmart. And I highly recommend just investing in some kind of storage system. It makes everything super easy. It's easier to find, and labels to label everything in your storage system. You could use label makers, and some of our images, as you can see, we just use like a piece of white gaff tape. So just label and organize makes the process go so much faster because, again, you don't have to spend time looking for parts. And then having necessary equipment. So on top of organization, it's important to have proper tools. And so veteran teams, this is less so for you because you often just acquire tons of tools throughout the years. But for newer teams, it's kind of important to have basic tools. So by designing your robot first in CAD, it's kind of easy to say, okay, so we'll probably need a drill for this, or we'll definitely need to sand down this, so we'll need to buy a hand sander. However, on top of that, there's really no kind of ways to know what tools you need. So it's just about buying a few things as you go. Some helpful tools are just T keys for whatever, for either empirical or metric, depending on what build season you're using. Rubber mallets are always super useful. Hand files, hand drills, nut drivers are all super useful. But again, it's just about building as you go. Because as you'll be working, you'll realize, oh, it would have been easier if we had this. And then so next season, or whenever you get a sponsorship, you could purchase those materials. And next, handling mechanical away from the workshop is really important. So when you go to competitions or outreach events, it's super important that you're also able to maintain your robot. In order to ensure you bring the right stuff with you when you go to an outreach or a competition, our team likes to use a packing list. So this helps us pretty much remember which parts and tools and other equipment we might need. There's been times where we try to bring stuff without this list, and it's just, we always end up forgetting something. And so having a physical list where you could just go down the line and just check stuff off is super helpful. So what we found to be helpful is just breaking everything up into different categories. So if you look, we have like hardware, tools, electronics, judging materials, pit supplies. So for certain events we're going to, we know what we might need to bring and what we might not need to bring. So for example, if we're going to an outreach event, we don't need to bring the control sheet. So we just will ignore the judging material section. And what we find to be super helpful is we have a printed out and laminated version of this. This way we're able to reuse it, and we just kind of use like an Expo dry erase marker and just check off stuff as we do it. And this way it's just super helpful to ensure that everything we need is going to be with us at some point. And this is having this list online is also super helpful because you'll find that even though you have a list of everything you're supposed to bring, you'll often forget stuff on the list. So as time goes on, you'll add to the list, and just having it written down is super helpful to ensure you don't forget anything. And next, how to stand out. Everyone has, or at least hopefully everyone has, some kind of robot, so it's important to make yours try to stand out to be recognized by judges. So one of the most important things is creating a smooth and sleek design. So in the past, our team has used shape optimization, which is basically the removal of non-essential material in order to reduce the weight of the robot. But you don't even need to do that, just making sure that your design is sleek and basically it has planning. It's like, hey, you could clearly tell that this robot was planned ahead of time. One of the best things that I find judges really like is trying to color different parts of your robot to match your team colors. So if you look on the image on the right, we had our robot powder coated. So the sides, which are metal, look blue, which is one of our team colors. Judges really like that because it just stands out, and it shows, again, how much planning you had and forethought. And it also makes your robot a lot easier to distinguish when it's on the field. Also, if you have a 3D printer that prints in different colors, ours unfortunately only prints in black now, but if it prints in different colors, that's such an easy way to tie in your team's color scheme to your robot. Next, having a design element, something unique that your team is proud of, is super important. There's been many times where judges come up to you either in the pit, or that's one of the questions they'll ask during interviews. What's something on your robot that you're proud of, or what's something on your robot that stands out? And having an answer to this is really important. Even if your robot is kind of quote unquote basic, having something that you're proud of is something judges love to hear, and it really helps you stand out. Because, oh, our team is really proud of our intake because it's really quick. That's kind of boring. Or our team is really proud of our intake because we actually went through several designs to get to this, and our last one before this didn't work at all, and so after that we went through and completely redesigned it, and learning from our mistakes, we made this design which is far more efficient and scores on average 20 more points than our other one. That stands out a lot more, and even though it's not necessarily unique, it makes your team unique. So just having something that your team can default to as something you're proud of or something you worked hard on is super important, and judges love that. And as I mentioned earlier, making sure your robot is consistent is super important. Even if it's not able to score high amounts of points, as long as it's able to consistently score points, judges love that. Teams that are able to score high amounts of points but don't always work aren't the best. The main goal of engineering, solving any problem, is being able to do it consistently, so having a consistent robot is super important. And now I'm just going to go over some FAQs, some commonly asked questions that our team has gotten regarding mechanical. So how do you come up with designs? So as I mentioned earlier, brainstorming, we like to just go through and come up with any ideas we might have off the bat, and we like to say that there's no bad ideas. So that's one of the ways we come up with designs. But another way is to just look at what your team has done in the past if you're a veteran team for similar problems, or look at other teams' robots. If you go on YouTube and search like FTC robot reveals, you'll see many different types of robots. And I'm not saying steal their designs, but you can definitely gain inspiration and see, oh, wow, this team used a sweeper intake and it worked really well for a similar challenge. Maybe we should incorporate that into our design. So it's all about just experience, knowing what works, knowing what doesn't, and learning from others, and also testing. You can come up with an amazing design and find out it sucks, but then using that information, you're able to design something that's the complete opposite. It may work perfectly. So it's just something you get better at as your team gets older. Now, what to do if a part or idea doesn't work? So hopefully, if you're testing along the way, it shouldn't be that much of an issue. What you could do is you can either redesign the part entirely, or what our team likes to do is try to figure out ways to make the part work. So if you're redesigning every part that doesn't work, you're gonna spend a lot of time redesigning. So instead, you can often make small adjustments. The biggest thing I can suggest is just testing, figuring out why it doesn't work, and seeing if there's an easy or simple-ish way to make it work without having to redesign the part. So again, it's just all about trial and error. And what's the best way to test ideas? As mentioned again, I feel like a broken record. Testing along the way is super important. So we like to build quick prototypes for any design we're going to do. So even if it's the middle of the season, it's like, oh, we're going to change our input system. We'll build a quick prototype. This way we make sure it works before we're committing to a design. Prototyping and then just seeing if that part would work in that spot is great. So for example, if we're prototyping, let's just say an input system, we'll build the prototype and then we'll just either hook it up to motors just quickly, or we'll even just spin it by hand or whatever. Make sure it's able to actually take in the game elements. And if not, we'll make changes or we just won't go with that design. How do you make / design prototypes? So a lot of times with prototypes, we don't really design beforehand in like a 3D modeling software. What we will do, however, is kind of draw it out on paper or use like a whiteboard, and then we'll kind of come up with basic measurements to ensure that it actually fits, and will be a realistic size. And then we'll just make it using metal, or a lot of times we'll just use channels from like our build kit. So we'll just stick together a few Go Builda channels and then attach stuff to it to make sure it works. And what are the essential tools for a new team? So this really depends. If you're going with a build kit, such as Go Builda, you want to grab T-keys, which are basically kind of like Allen wrenches or Allen keys, but they have kind of a T-shaped handle at the top, which allows it to be easier to grip, which makes screws easier to turn. But also, if you're on a website like Go Builda or even Tetrix, it'll give you a list of suggested tools and parts, so I recommend that. Besides like T-keys and Allen wrenches, I recommend like a rubber mallet. I recommend obviously like a bandsaw or some kind of saw, a hand drill or drill press, some kind of vice grip. Yeah, I think that's pretty much it. And as you go, you'll see pliers are also really good. You'll see stuff that you need and you'll make changes accordingly. And what's the best piece of advice I have for a new team? It would just be to not give up. There's going to be a lot of stuff. Nothing's going to work right the first time. But the more you try, the more you redo, the more you practice, the more you test, the better your design will get and the better as a team you'll get. So I just keep trying, don't give up. And I know it can be overwhelming, but it's important to break things up into small, easier steps and make it work that way. So that was our presentation on mechanical. I hope it was somewhat helpful. And as I mentioned earlier at the beginning, if you have any questions, you can email outreach@sufferingrobotics.org or reach out to us at Suffering Robotics on social media, and you could check out our website for more information about the team. And thank you guys for listening. I hope this was helpful.
Welcome back, everyone. I hope you all learned from that detailed presentation on design and fabrication. Our final presentation for today's conference will be presented by Tigerbots from California, USA, who will be talking about engineering notebook and portfolio documentation. By now, you all know the drill, but just a reminder to keep putting your questions in the chat. Let's hand it over to Tigerbots.
Hello, we are the Notre Dame Belmont Tigerbots, FTC Team 7593. We're an all-girls team from Notre Dame High School, Belmont, in California, and we were founded in 2013 by 2 sophomores who saw the need for a place where girls at our school could feel comfortable exploring STEAM. Our rookie season was Block Party in 2013 to 2014. This is our 9th season. We focus on giving students the opportunity to explore engineering and to develop leadership skills. And on the right, you can see a picture of our team. And today we are going to be talking about robust documentation. We are going to be going over the engineering portfolio and notebook. We are going to leave no corner unturned. So, why is the engineering portfolio important? Why is the engineering notebook important? It can get a bit tedious making it for a lot of people because it's basically a record of literally everything you do. But it's very important. It's very important that you do it because, for one, it's your team resume. It's a summation of all your skills and all your experiences and all of the work you do in a single season. And it can be your first impression on people. Like, for example, if you're going to competition and, you're getting judged. The judges, the first thing they see of you could be the engineering portfolio. So you're going to want to make sure that that makes a good first impression on the judges. Or if you have new recruits and you're bringing them onto the team and maybe you want to show them a snapshot of what you've done in the past, the engineering portfolio is a great way to do that, and that would be part of your first impression you make on other people. So you want to make sure it looks good. You want to make sure that it's throughout. Yep, throughout. You want to make sure it's throughout. And then at competition, like I said, all your judges are going to look at your engineering portfolio also to determine awards. Which brings us to our second point. You need the engineering portfolio to win awards. Pretty much all of the awards that you can win in a competition require you to have the engineering portfolio. So you're going to want to make sure to have one every season. It also helps you learn from past experiences. So you can improve on any past build designs you've maybe done over the years. You can see any outreach you've done. Think about maybe reconnecting with a sponsor who you lost touch with. Overall, it can help you improve just by looking at all the past experiences you've had and saying, how am I going to change this? How am I going to move forward as a team? And it was especially helpful for us, especially after COVID, because we were able to look at the things that we've done before COVID and say, hey, how are we going to change our trajectory now that COVID is here? And how are we going to adjust for social distancing and all these other accommodations we have to make? Last point on why it's important is team history. Your engineering portfolio is basically a snapshot into parts of your team. And especially for older teams, the engineering notebook and the engineering portfolio can serve as kind of a snapshot of who you were in those years. And it's really, really fun to look past at your past ones that you've done and look and see where you were maybe 4 or 5 years ago. And it's also really great for showing rookies, showing them how your team has grown, showing them what you've done, like I said, and how you've changed as a team. So, with the importance of engineering portfolio established, I'm going to go over the outline of our presentation today. First, we're going to go and look at what's up with the engineering portfolio and the notebook. What is it? Just have a general idea of what they are. Second, we're going to look at the requirements for the engineering portfolio. Specifically, what does the game manual say about it? What are the page limits you have to hit? Number 3, we're going to look at what's good in an engineering portfolio and what's bad in an engineering portfolio. What works, what doesn't work, what's a little bit confusing. Number 4, we're going to look at personally helpful things that we've learned, the Tigerbots as a team, over making the engineering notebook and the portfolio for all these years. And number 5, we're going to look at what actions make a good EP. So what habits can your team get into that will help you make a successful engineering portfolio?
So starting with the history, what is engineering portfolio and notebook? The engineering notebook is like a complete documentation of the team. So you might want to include things like outreach, fundraising efforts, team plans, robot design, programming, and electronic. Basically everything about what you have done. The engineering notebook should include like sample sketches, discussions, team meetings, design evolution, processes, obstacles, goals, and plans to learn new skills, as well as each team member's concise thoughts throughout the journey of the season. And for the engineering portfolio, it is more like the team's cover letter or resume. So next we'll be talking a little bit about the difference between the two. Portfolio is concise and notebook is detailed, which is like much longer. Portfolio is like telling others about a team story, but notebook is like a documentary of the team,
record for future reference. Portfolio is like in progress, it is talking about the team status at the moment, basically about what you have done and what you plan to do in the near future or the rest of the season. Notebook is complete, it documents everything happened during the whole entire season, and it is optional. So in short, like an engineering portfolio is like a short and concise summary of the content collected within the team's engineering notebook.
Okay, now we are going to go with some basics. We are going to look at some of the requirements for the engineering portfolio. So what goes inside the portfolio? What are all the requirements you have to hit? So first of all, the most simple, obvious limits, size limits. Your engineering portfolio can't be longer than 15 pages, not longer than 16 pages, including a cover sheet. Just so you know, it specifies this in the game manual. The control award form does not count in your count for pages. So 15 pages, discounting the control award form. Font-wise, you can't have anything less than a size 10 font. So I'm sorry, you cannot cram tiny words into every margin of the page in your engineering portfolio. Even though I know some of us have a lot of things they want to say about their team, you have to be concise. There are no links allowed to other documents, no links to videos or additional content. The judges will not look at them. And for more detail, if you want to look at the nitty-gritty specifics, you can go to the first website and look at the engineering portfolio section of the game manual. I believe it's on page 49, and it'll just help give you a better, more specific view of what's required for the engineering portfolio if you have any more questions about that. Okay, so now we're moving on to content requirements, the fuzzier bit, the bit where you get to decide what goes in and what goes out. So you are recommended to include team info, just general team things, team plans, outreach events, robotic design processes, and anything relating to programming or electronics. Basically just an overview of your team. So first of all, we have team info. This really tells the anybody who's reading, your reader, who your team is. What role do each of the members play? It can be a little bit of history about your team. If you're an old team, you probably have a lot of history to say. It can include team bios. It can include goals for your team, like what aspirations did you have at the beginning of the season? What aspirations do you still have now? It's a great place to put all those things and get a little bit of your personality out there. Team plans. So team plans are just what plans does your team have for advancing forward through the season? For example, what's your plan for sustainability? How are you going to handle it if you're a school team, when your members graduate? How are you going to handle it when your members leave? If they do, when they do. How are you going to train up new recruits? How are you going to find new recruits? All of that good stuff, which kind of bleeds into recruitment. Yeah. And fundraising. How do you fundraise your team? Are you fundraising it on GoFundMe? Like a site where you can raise money for your team? Are you doing bake sales? Are you getting corporate sponsorships? Are you holding a team fee? How are you getting the money? I don't know. Maybe you're selling plushes. Just list that. That's something you should include in your portfolio. And business and marketing, finally. This would be anything that you've done for your team to market it. Maybe you're marketing it at your school to the wider public. This would be any flyers you have made or any maybe announcements you've made to just have people learn about your team. Any way that you've tried to let people know that, hey, you're here, you're recruiting. Anything on social media, maybe anything that you've done to like showcase your robot. Like what have you done to showcase that you're a robotics team, basically.
Next would be your outreach event. The first one that I want to include is your community outreach. It is what your team have done or provide for the community. For example, our team, we have an event that introduced robotics to local Girl Scout troops and helped them to earn their robotic badges. So on the engineering portfolio, we will include what we have designed for this event, like our curriculum. The other type of outreach would be the industry outreach, where your team have reached out to that helps the team to develop into gracious professionals, like connect with people or company from STEM industry and help them talk about their experience. For example, we contact alumni and got some guidance from her on how to improve our robot during the season. So on the engineering portfolio, we will include some of her guidance. Shifting to the next part of the content, robot design process, including brainstorming problems along the way and your final design. For brainstorming, you want to include how you come up with your sketches or design. Like starting out with writing down the point for each part and think about your strategy and where you want to focus on getting points at. For example, we know that we want to get points for spinning a carousel and push the duck out. So we would think about what we need to do, which is having like a spinning wheel, which is the green part in the picture. You might also want to include problems or challenges along the way, usually 2 to 3 of them, like shipping issue that affect building progress. And last but not least, your final design. You might want to include specific mechanism, like what we have in the picture. Our main mechanism, which is like a 3D printing box. Lastly, for the programming session, talk about your programming process. For autonomous, talk about your strategy and how you code accordingly. For teleop, talk about how you code and work with the drive team, like one thing that you have done to assist the driver. You may also want to include like a unique aspect of your code. For example, our team, we have like the reusable code that we extended from the FTC class, which you want to include that in your portfolio and describe how that helped. Lastly, include a brief description of the sensor that you use and how they help your robot function. The next topic is learning. What works best in engineering portfolio and what doesn't. So we'll be talking about what we learned from other teams' portfolio and from our own experience. In general, you want to have pictures. You want to have pictures as much as possible. Like you want to have pictures on your design, sketches, as well as your game strategy. You could add some graphic design to decorate your border or framework. You could add some icon so that your portfolio will not come off way too boring. You could also add some CAD design diagram. Like for example, what we did is that we have the diagram at the right side along with a picture of what it actually looked like.
Second tip on effective engineering portfolios is about conserving space. So obviously everybody wants to conserve space on their engineering portfolio because we only get 15 pages, and when you get down to it, 15 pages isn't a whole lot to fit all of the content you need to fit in your portfolio. People usually deal with this by making the font as small as possible and then cramming it all into dense paragraphs. Now, this is a very fast way of doing it, but not exactly the most easy to read way, because people have a hard time skimming really dense paragraphs when they're trying to read something very fast. So we suggest that you find some creative ways to break up your text and make it easier to read while still making it nice to look at. There are multiple ways you can do this. Mainly you just have to be creative about doing it, but on the right we have an example of how you can organize and break your text a bit easier. So here we have a couple of bullet points, a couple of definitions with hyphens, with bolded words and highlights. We have a sentence that's different size than the rest of the words, and it's all broken up into boxes. All broken up into boxes, and the boxes are just a chart with a couple of merged cells in them. And we suggest you do something like this, just because It's a lot easier to read, a lot clearer overall, and it's just nicer to look at than dense paragraphs. Our next tip is a pretty big pitfall we've seen and done. It's over highlighting. Do not, and I mean do not over highlight. It's very tempting to highlight tons and tons of words because you have tons of things you want to emphasize. But as you can see from the slide, it doesn't work very well when you highlight too many words. If you over highlight, all of the words you highlight blend together because it just becomes an ordinary part of your formatting. If you don't use it very rarely, it isn't very special. So all the things you try to highlight will just get muddled and lost. It's best, we suggest, if you think about highlighting 5 to 7 words, maybe think about highlighting half of that, like 2 or 3. I know it seems like a very small number compared to what you want to do, but it's best to have those 2 to 3 words highlighted. Our third tip is to include all the skills you've learned. So, for example, did you do fancy math to build the robot? Did you do fancy physics? Did you do fancy programming or engineering? We suggest that you include all proof of that, everything that you've done regarding that. If you have any physics equations, any math equations, put those in. If you have any pictures of the programming you've used, put that in. Again, any pictures of engineering, like any CAD models, any diagrams, put those in as well. Include it because all of these are very fuzzy topics. All of them need very abstract understanding. And visuals can really help judges see that better, especially in a digital format where you can't necessarily bring supplemental materials to a judging interview. Okay, these are some advice and some personal tips from the Tigerbots to you about what worked well for us from our engineering notebook and our engineering portfolio making. For starters, we've learned to use all the visuals that we can. We suggest you do the same because people like diagrams. I bet up until now you were a bit sick of the bullet points and the lists we've had in this presentation. So here are some circles to break up that monotony. People like diagrams because 1, like I said, they break up the monotony of text, but 2, they're also a great way for showing information differently. Like for example, if you need to chronologically show information, it might be best to move away from paragraphs, move away from bullet points, and instead move towards something that can show your information a bit more chronologically, like a flowchart or maybe a timeline. It's just more easy to understand and better on the eyes. At the right, you can also see a chart, which is a great visual to use as well. Just another way of breaking up information. Our next suggestion would be to go digital. It's very, very easy to edit your engineering portfolio when it's digital. It's also easy to access. So for example, especially with COVID, this is important because from our experience, the Tigerbots, we've had to only have certain people at certain places at certain times because of social distancing. Like at the shop, we've only been able to have certain people in there, and maybe we have 2 people there and 2 people at home, and both groups need to add to the engineering portfolio. It's way easier to have it online where everybody can access it instead of having 15 physical pages that we're writing on, 15 physical pages that we're editing, that would have to be swapped back and forth. That just would be very frustrating. So it's easy to access, easy to edit. You can make drafts, as many drafts as you need without breaking your hands, trying to rewrite, re-ink, all of that work. You can Control-Z your mistakes away. It's very easy to just edit, easier to organize. You can section off your document very well just because it's very easy to label, very easy to do, for example, a table of contents. A table of contents would be a bit easier and more effective to use with an engineering notebook. Maybe something a bit more dense. You might want to, it's not for everybody, for the portfolio especially, because it takes up space, but it is a pretty good method of organizing a very dense document. We highly recommend it. The document outline in Google Docs as well, if you use Google Suites. Both of those tools are very helpful. And there are also, if you go digital, very nice royalty-free visual templates all over the internet that you could just use for your engineering portfolio. Like, for example, this slide deck. There are lots of great royalty-free visuals you can put in. Plenty of charts that you would not have to ink by yourself or draft by yourself by hand. Our third and final tip is to just be organized. In person, we suggest keeping Post-it tabs in your portfolio on the parts that you want people to see. Maybe you want a judge to see a specific huge outreach event you did, or maybe you want to highlight an incredibly crucial or innovative build design you did. You're going to want to put a Post-it there and be very sparing with the Post-its you put in, because just like highlighting, it is only best used sparingly. On highlighting, if you're going digital, if you are not having a physical engineering portfolio, it might be a bit hard for you to put Post-it tabs on it. You can't do that. So our suggestion, if you want to do something like that, is just highlighting. Again, you have to be very careful about that. And as the example on the slides say, we suggest that you highlight any numbers, any really crucial parts you want to highlight.
The last topic will be on what actions make a good engineering portfolio. Some habits that help. You always want to take pictures. People at most time do prefer pictures over a chunk of text. And of course, you need to take them over time. It's like your team history. But instead of writing it out, you are taking pictures. And it's very easy for people to forget to take pictures. So in that case, you might want to have like camera person. And do keep screenshot of your sketches and model. Consistency. Again, you do want to take photos over time. Do not wait until the day before to put everything together. So when you're taking picture, you might want to write a brief description of what happened in that picture or at the moment. And then you do want to have different photos for different sessions. So for this picture is for business. You want to put it into the business folder. So that when you're working on the engineering notebook, you can just go to a folder and go through the pictures and select them. You might also want to make a record of what you have done over time. Like one thing you could do is meeting logs. Or write down reflection and summary of what happened during that week or month. Lastly, you do want to make drafts for your engineering portfolio. Do not just go with your first draft. So at the very beginning of a season, just have one document ready, add, delete, or edit the content inside.
Another important thing to keep in mind is consistency with branding. So that includes making sure people know your team's logo and keeping a theme in your engineering portfolio. It's especially important because just imagine in a competition, you submit your engineering portfolio to be evaluated by the judges. They're reading through maybe their 10th engineering portfolio and it just happens to be yours. They're on the 11th page and maybe you did that in a separate font or a separate color and it doesn't look uniform with the rest of your portfolio. The judges could remember that and then get confused because it doesn't look like the rest of your stuff. It could be very, very detrimental to how you're scored. So we suggest just keeping a theme, making sure that all the work you do is recognizable as belonging to your team. And we suggest doing that with consistent colors. So on the right, we have a lot of the colors that we use for all of our marketing materials. So we have white, yellow, blue, green, all of the colors we have inside our logo. And if you look at the presentation colors, we did the same thing here with the presentation. The presentation's blue, it's white, it's gray, a little bit of yellow in there too. It's not the exact shades that we usually use, but we feel it's uniform enough that it goes with all of our other marketing materials. And that's really important. Uniformity is really important. We also suggest for your engineering portfolio using clear, legible fonts. So this top font is the one that we like using because if you have a block of text, like a paragraph, you just can't avoid breaking it up. Not can't avoid breaking it up, but you can't break up the text. You have to have a paragraph in there. It's always best to have the font for that be clear and legible so that the judge can skim over it, or whoever's reading can skim over it. You can imagine it would be kind of hard to skim over a paragraph entirely written like this in this font. So just making sure that you use consistent fonts, that everything is more or less similar sizes, and that it's legible. Okay, another crucial part about having a good engineering portfolio is being good about assigning people's parts for the portfolio. Now, no one person on any team bigger than 6, no one person can do the entire engineering notebook or portfolio. It's just not possible. So you need to make sure everybody does their part. Especially for people who are working on the robot, it might be a bit hard because, you get so swept up in the joy of creating something and maybe applying something new you've learned or making a mechanism work that, documentation comes as an afterthought. You don't really think of that in the moment. It might be tedious to do that and to record after you invent something or you apply something every single time, but it's important. It makes for a very robust engineering portfolio and a very thorough look at what your season was like. So if it helps, we recommend doing meeting logs, as in notes of every single meeting that you have. So maybe assign somebody to do them, and you can then take the highlights of those meeting logs and turn them into your notebook sections. From there, the notebook turns into the portfolio, and boom, you have a method to approach the portfolio without just trying to aimlessly put words down for it. It teaches new members about your team as well, as a side benefit. If you have them do the notes for the meeting logs, they have to learn about all of the team, what everybody does, and it's a great learning experience for all new rookies. And that's it. That's the end of our presentation. We would like everybody to keep in mind that there is no one right way to go about engineering portfolio. At the end of the day, engineering portfolio is just a reflection of your team. It's just a reflection of what you've done. It's just how best you reflect what you've done through all these mediums. So just pick and choose what works the best for you, and we wish you good luck. And thank you. If you have any questions for us, just make sure to pop it into the Q&A. If you have any additional questions after the Q&A, just email us at team7593@gmail.com. We will get back to you as soon as we can and answer you as best as we can. We promise.
This brings us to the end of the 3rd annual WorldShop FTC Conference. I hope you all learned something new by listening to the perspectives and experiences of teams from all across the world. A huge thanks to all of our presenters, and once again, I'd like to extend a special thanks to First Updates Now for hosting us here on Twitch. We've recorded the entire conference and will be making it available on the Revamped Robotics YouTube channel at youtube.com/revampedrobotics. Thank you everyone for joining us, and have a wonderful rest of the day.